Good morning, everyone. So today we are going to start a new training on the Microsoft SQL Server. So a brief about me. Myself Vijay Rathod, and I am a Microsoft SQL Server developer with 10 plus years of experience in building high performance scalable databases. I am skilled at the query optimization, system tuning, designing solutions that ensure the data integrity and support critical business operations. So today we will go through the theory and mainly focus on the practical skills that you need to be effective SQL Server developer. So my goal is to make these complex topics accessible and directly applicable to your works. Let's start it. So this is the roadmap for today's training. So the fundamentals: what is the SQL Server? DBMS and RDBMS, the core engines, the editions, features and the services, architecture, system databases and physical files, database design, data model, normalization and constraints, the languages of SQL, data types, operation and command sets. After that, we can go through the practical skills like DDL, data definition languages, nothing but the create, alter, drop. Practical second, that is DML, data manipulation languages, insert, update, delete, and truncate. Practical set third, DQL, select, filtering, sorting, and grouping. Also, we will consider advanced concept like subqueries, identity, and sequence objects. So before starting this training, we need a Microsoft SQL Server so that we can download from this link. Okay, I have here is the link. From here you can download the appropriate software version. This is the SQL Server developer that we are going to use in this training. Let's start it. First we will go through the theory, and after that we will uh, do the real-time examples. So what is the SQL Server? So SQL Server is a relational database management system which is developed by the Microsoft. It's the engine that allows to efficiently store, manage, and retrieve structured data. SQL Server is a relational database software used to store the large amount of data or information in tabular form. So the evaluation of, of the database from the files to the relations. So here is the file management system, then DBMS, then RDBMS. In file management, we can store the data in simple text files with no relationship. In DBMS, we store the structured database and some management tools. In the RDBMS, we use the table-based relational, more powerful and consistent database. So here is the continuation of that evaluation part. What is the file FMS? FMS is nothing but the file management system, and it is used to store, manage, and access data from the text files. DBMS is nothing but the database management system. It is introduced in 1970s. In the DBMS, data is the collection of related informations. Database is the base or layer to store the data, and DBMS means it is used to store, manage, and access the data from a database. In DBMS, data is stored in form of table which contains rows and columns. So the example of DBMS is Fox Pro, DBase, and MS Access. Now, we can focus on the RDBMS, which is nothing but the Relational Database Management System. So, RDBMS is a software used to create, manage, and interact with the databases that follow the relational data model, which meaning data is stored in the table in the form of rows and column, and maintain the relationship between those tables are defined using the keys, nothing but the primary keys and the foreign keys. RDBMS combines relational feature with the relational data models. So, key points of the RDBMS are tables. In table, data is organized in the table instead of the files. Relation. Uh, which means table can be linked to each other through the relationship using the primary keys, foreign keys. Okay. So SQL. Most means SQL is a structured query language. Most of the RDBMS use structured query language to query and manipulate the data. Constraints. It enforces rules like uniqueness, referential integrity, and the data types. Transaction. Transaction supports the asset properties, which are atomicity, consistency, isolation, durability, to ensure reliable data operations. Example of the RDBMS: Oracle, Sybase, Ingress, Informix, DB2, MySQL, and the SQL Server. So now we can see the key differences between the Oracle and the SQL Server. Here is the table for that. Feature, uh, platform, Oracle. Oracle is a platform independent, works on Windows, Linux, Unix, etc. But the SQL Server is platform dependent and it can only works on the Windows OS. Programs can execute .NET and Java programs. SQL Server executes only .NET programs. Interfaces. Oracle is the CUI, character user interface, and the SQL Server is the GUI, which nothing but the graphical user interface. Okay, so the core concept of RDBMS. Okay, relational databases, SQL languages, transaction, and the security. These are the core concepts of the RDBMS. Relational database means data is organized in the tables, and tables are linked using keys like primary keys, foreign keys. For the customer table, customer ID links with the customers to the order. SQL language. This is how you can talk to the database. Means you use SQL to select data, insert new record, update record, delete record, and much more. Transactions. SQL Server supports transaction to make such sure operations are reliable. Make sure operations are reliable. For example, transfer money between two accounts, both the withdrawal and deposit should succeed or neither happens. Security. Using means SQL Server uses the authentication, login credentials, encryption, and role-based permission to keep data secure. Uh, Now the DBMS features. Following are the DBMS features: the redundancy and inconsistency, security. Security can be provided through the authentication and authorization, data integrity, and the atomicity. In a transaction, a set of transaction is nothing but a set of SQL commands. Uh, Either all command executes or none of them executes. A transaction is unit of works. The It guarantees asset properties, and asset properties nothing but the atomicity, consistency, isolation, and durability. RDBMS features. In the RDBMS, we can store large amount of data. We can use the SQL, that is structured query language, for the means retrieval of data or inserting data or updating data. We can join multiple tables, okay, and it supports relationship between tables like one-to-one relationship, one-to-many relationship, many-to-one relationship, and many-to-many relationship. So the data models are used to define different ways of storing information in the database. There are three types of data models as following. First, the physical data model, conceptual data model, and the logical data model. So the physical data model defines how data is physically stored in the database. Conceptual data model defines what data is stored and relation between the data, often displayed as a diagram. The most famous example is the entity relationship diagram. Logical data model defines what data is stored and the relationship ships existing between the data. There are five types of logical data model. Those are hierarchical data model, network data model, relational data model, object data model, object relational data model. So the logical data model continues. Hierarchical data model. Okay. Here is the diagram how the data is stored. Okay. Consider means in hierarchical data model, data is stored in a tree-like structure and it supports one-to-many relationship. Example, IMS, information management system. In the You can see the diagram. Here is the organization, that is Tech, and in our organization we have different project like HMS, CRMS, HRMS. So one organization have multiple projects, means one-to-many relationship, and multiple pro means one project have multiple employees. Okay, like HMS, for HMS project, Ram and Vijay are the employees. Those are working on HMS project. For the CRMS, Ajay, Sanjay, and Surya, those are the employees working on the CRMS, and the HRMS, Anil and Sunil are working on those project. Okay, so here project is one, but it has multiple employees. In the CRMS project is one, multiple employees are working like HRMS. Okay, now come to the next logical data model, which is nothing but the network data model. So in the network data model, data is stored in the tree-like data structure and it supports one-to-many and many-to-one relationship. In this model, data access and manipulation are very difficult. For example, information data stores, IDS. Okay, let's see the diagram. Here is Tech is the organization. Okay, in Tech, we have different projects like HRM, CRM, and HRMS. Okay, now here it maintains one-to-many relationship. Okay, so in HRMS, HRM have different employees, and here we maintain the one-to-many relationship. Okay, we in HRM employees are different. Okay, like Vijay, Vinay, and Akhil, and in CRMS, uh, Akhil and Surya are working. So here Akhil is common for the HRM and the CRMS. So The multiple project can have same employee. Okay. Same is for the CRMS and HRMS. Here Surya is common for Surya is common for CRMS and HRMS. So it maintain many to one relationship. Okay. So likewise, it is very difficult to manage. Third logical model is relational data model, and introduce it. This model is introduced by the EF Cord in 1970s. He introduces 12 rules that relational databases should follow, and in this model, data is stored in rows and columns. Example: SQL Server. Object data models. It is used to implement object-oriented programming concept. Example: Cactus software and the object store. Object relational data model. It is the combination of the object and the relational data model. Example of Oracle. So we have a different SQL Server editions. Okay. Microsoft offers different version for different needs. Choosing the right one is the key architectural decision. So following are the editions of the Microsoft SQL Server. The first one is the SQL Server Express, SQL Server Developer Edition, then SQL Server Standard Edition, and SQL Server Enterprise Edition. In SQL Server Express, it is the free and lightweight, and it is perfect for the learning, small project, and the lightweight applications. SQL Server Developer is a free and has all enterprise features, but it's licensed only for a non-production development and testing. SQL Server Standard, the workhorse for many mid-sized business, offering a robust set of core features for production use. SQL Server Enterprise, the top tier edition with the advanced performance, security, and the high availability features for critical systems and mostly used for the productions. A brief history about the SQL Server. Okay, so we means SQL Server was introduced in 1989, but we can consider the stable versions since 2000. Okay, so SQL Server version, internal version, release year, and the features. The SQL Server 2000, which has the internal version like 8.0, and it is released in the year 2000. Here are the feature like it supports the XML supports indexes, views. Okay, XML supports index to views, user defined functions, cluster improvement. Then next SQL version was released in the year 2005 as internal version 9, and the SQL Server NEST 2005, and it has the features like SQL Server Management Studio, CLR integration, dynamic management views, service broker. Then in year 2008, SQL Server 2008 was released with the internal version of 10.0, and it has the feature like data comparison, policy based management, improved security. Then in 2010, 2008 R2 with the internal version 10.50 was released, and it has the feature like BI enhancement, master data services, scaling out reporting. And in year 2012, the SQL Server 2012 was released with the internal version of 11, and it has key feature like always one, availability groups, columns, store indexes, TSQL improvement. In year 2014, SQL Server 2014 was released with the internal version of 12.0, and it has the feature like in-memory OLTP and the buffer pool extension. In the year 2016, the SQL Server 2016 was released with the internal version 13.0, and it supports means its features like it has support for JSON, it has support for temporal data, row level security, strength and database. In 2017, SQL Server 2017 was released with the internal version of 14.0. It supports means it has the feature like Linux support, Python integration, graph database supports. In year 2019, SQL Server 2019 with the internal version 15.0 was released, and its key features are like big data clusters, intelligent query processing, enhanced security. And in year 2022, SQL Server 2022 with the interversion 16 was released, and its key features are Azure integration, cloud linked features, enhanced disaster recovery. So what makes SQL Server powerful? So the following points makes SQL Server powerful, like TSQL, Transact SQL, SSMS, high availability and disaster recovery, .NET CLR integration, business intelligence tools, and scalability. Microsoft's powerful extension of SQL, adding programming like logic like stored procedure functions and error handling. Okay, SSMS is it is nothing but the SQL Server Management Studio is your command center. Okay, SSM is nothing but the graphical tool to manage databases, run queries, and monitor performance. High availability and disaster recovery. Its feature like always on replication and failure clustering helps a system running even if something fails. .NET CLR integration allows you to write database object like store procedure and function using the .NET languages like C#. Business intelligence tools, integration with tools like SQL Server integration services, reporting services, and analytical services for ETL, reporting and analytics. Scalability. It handles a small databases to huge enterprise system with the terabytes of data. So inside the management studio, you see the following objects, means following things like object explorer, query editor, register, services. So object explorer is your main navigation tree used to manage all the database servers and their objects like databases, tables, security, and it runs on the port 1433 by default. Query editor uh, this is the window where you can write and execute the SQL commands, and you can press F5 to run your script or your query. Registered servers allows you to register and manage connection information for multiple servers, making it easy to switch between them. So you can create an instance or a copy of database servers, click on view register services, right click on local server groups, new server registration, server name like my server one, connection properties tab, select the database and save. So we can see this in practical. So here, okay, let me show you. This is the object explorer. Okay, so in object explorer you see the databases. In the database here is a database name. Okay, one database I have already created. It has the security features, means we can provide the security by using this logins, server roles, credential audit, SQL servers, specification. Okay, it has the server objects like backup, link servers, triggers, replications, then polybase management. Okay, here you can give the policy. You can set the policy here and the profiler. Okay, this is the object explorer. Now the query editor. Okay, second one is the query editor. So from here or from here, okay, you click no from here. If you click on this new query, then the query editor is will open. Okay, and here you can write your queries like select start from. Let me check the table in the ABC table. Oh, I don't have any table here. Okay, so like employee. Okay, like you can write your queries in the query editor and the register servers. Oh, from here you can connect to integration services. Okay, in the from the view, go click on the register servers, and here you can see the database engine. Okay, and the local server groups that we have already discussed. Okay, now okay, the types, the SQL Server platform services or the server types in SQL Server. There are different server types in the SQL servers, nothing but the database engines and analytical services. Okay, this is the default server type, database engines, and it is used to store, manage, and access the data from the database, and it works with the online transaction processing databases, and in any .NET projects or application will be database is used. Analytical services, it can be called as a data warehouse, and it is used to maintain old data of any company or business, and it uses the online analytical processing database. The reporting services, uh, it is a reporting tool which used to generate the reports in the various formats and the types of reports like standard report, ad hoc report, embedded reports. The integration services, it is used to transform or used to convert data from one format to another format. In integration services, 27 transformation can be done, and it is called as ETL, which is nothing but the extract, transform, and the load. System databases in SQL Server. There are four types of system databases: master database, model, MSDB, and the temp databases. Master database is used to perform the user and administrative tasks and used to manage SQL servers. All the system program or predefined program will be in the master database model. It is the template for the new database. Based on the properties of the model database, new database will be created. MSDB stands for the Microsoft databases and used to store the job history for SQL Server agent. Job history will contain the SQL commands executed by the users, and it is used for the data recovery. Temp database means temporary databases. Whenever SQL Server is started, the temp DB will be created. It is used to store temporary data and the temporary store procedures. So let's see where we can find this for databases in the SQL Server Management Studio. Okay, Now if you go here, okay, click on the database, expand these databases, okay, system databases. Here you can find the master database, model database, temp data, emsdb database, and the temp databases. Okay, now, so what is the database and where data physically lives? Okay, before that, SQL Server instance can contain up to 32,767 databases. Okay, here this diagram shows the types of files. Okay, the primary data files and the log file. In the primary data file, we can store the tables, views, indexes, synonym sequences. So primary data file, we can means it has the extension of .mdf, and it contains the startup information of the database. It is used to store the tables and other objects. The file extension is .mdf. Log file, transaction log file. It is used for the data recovery. If the data is lost, to get back it again, then log file is used. The file extension is ldf. And the secondary data file, if the primary data file memory is full or no space is there, then secondary data file can be created to store the tables and other objects. So logical files versus physical files. Logical file will store in the SQL Server or in the SQL Server Management Studio, and the physical file will store on the operating system. Logical file contains the reference or the memory address of the files in the OS. So you can find the files in the below location. Like for means for my local is my PC name, changing in it. Okay, C program files, Microsoft SQL Server. This is the version of SQL Server with the name, PC name, MS SQL data, and in the data you can find two files. One is means database name.mdf. This is a primary file, and this is the ldf file. Now, how we can design a database? For the designing database, we use the normalization. So normalization is the process of organizing your tables to reduce the data redundancy and improve data integrity, and it involves decomposing large complex tables into smaller and more manageable ones. Why the normalization is important, or the advantages of the normalization? Using normalization, redundancy can be reduced, inconsistency can be avoided, and the related data is stored in the tables. What are the normal forms? There are four normal forms, which are first normal form, second normal form, third normal form, and the boys quad normal form, which is the BCNF or the 3.5 NF. Let's take the example of this. Okay, so unnormalized form. Okay, this is the bad design. So all the data. Okay, so let's take the example of orders raw table. Okay, so all the data is jammed into one table, that is the orders raw. Let's see the structure of this table. Okay, it has the order ID, customer name, customer address, product 1, product 2, product 3, and the total amounts. Okay, so here we have below problems like the repeating columns. This table has the repeating columns like product 1, product 2, product 3. Customer info is repeated for every orders. Okay, and the updates are messy. If address change, must update everywhere. So for to work on those, we can use first normal form, second normal form, third normal form, and BCNF. Okay. So in the first normal form means first normal forms means all the columns in the table must be atomic. Means every column should have a single value. Repeating groups or duplicate columns are not allowed. Okay. Using first normal form can increase the data redundancy as there will be a multiple rows with the same data, but each row now has a whole unique values. Okay, so now let's split that orders raw table into two tables like orders and the order table. In the orders table we have the order ID, customer name, customer address, and the total amount. And in the order tables we have order details id, order id, and the product id. Means here order id is the primary key in the orders table, and in the order details order id is foreign key, means it's related to the order table. So in the first normal form we fixed. So in this, each product is a row in order details table. We have removed the duplicate from the orders and not multi-valued fields. Okay, but the problem here is that we still have the redundancy in the customer data in order table. Okay, now come to the second normal form. In the second normal form, all the column in the table should functionally depends upon the primary column, okay, in the table, and make sure it follows the rule of first normal form. Partial dependencies are not allowed in second normal form. So here the problem is that product name depends on the product ID, not on the full, that is order ID, product ID key. So here are the tables, customer table and the order table. Now along with we have created one table, that is the products, product ID, product name, price, and also created another table, that is order details. In the order details we are storing order ID, product ID, quantity, primary key, order ID, product ID, foreign keys, order ID, that is referencing to the order ID of the orders table, and the product foreign key product ID references to the products product ID, means product tables product ID. So in the second normal form what we fix, uh, a product tables has the product information, orders table links to the customer and the products, and no partial dependencies. Third normal form 3NF. Now third normal form should follow the rule of second normal form, and all the columns should depends upon the primary key column in the table. In the third normal form, transitive dependencies are not allowed. Transitive dependency means non-key column will depend upon the another non-key column in the table. Suppose we add zip code incorrectly like below, means alter table customer add zip code varchar 10 city. Now city depends on the zip code, not on the customer ID. That violates third normal form. So the correct design is means correct database table design is that we create a new table that is zip codes, and we can drop the columns from the customer table, and we can add zip means we can add zip code uh, to the customer table. Okay, referencing to the zip codes of the primary zip code. Okay, now city depends only on zip code, not directly on the customer. Transitive dependency, customer ID, zip code, city is removed. Okay, now the last one is voice code normal form BCNF 3.5 NF. BCNF is the advanced version of 3NF, and it is stricter than 3NF. A table should be in a BCNF if every functional dependency of X equals to X such that Y, where X is the super key of the table. Okay, for BCNF, the table should be in a third normal form, and for every functional dependencies, the left hand side is a super key. Every determinant must be a super key. Note: functional dependency X such that Y means if you know X, then you can uniquely determines Y's value. Super key means a set of attributes that can uniquely defines every row in a table. Now, order ID, customer name. It is okay because order ID is primary key. Now, order ID, product 1, product 2, product 3. It is also okay because means order ID holds the information of product. Now, customer name and customer address. It violates the BCNF. Customer name is not a super key because a customer can have multiple orders. Total amounts depends on the product. Transitive dependency violates BCNF. Conclusion: this table does not satisfy the BCNF because of customer info dependency. Customer name depends on the customer address, and the product stored in the multiple columns, that is product 1, product 2, product 3, and creates repeating groups and transitive dependencies to the total amount. This table is not satisfy the BCNF because of the customer info dependency and the product stored in multiple columns. To fix this, we can decompose the table into multiple tables like customer tables. Okay, in the customer table should uniquely holds the customer information. Then we can uh, create a product table, order tables. In product table, it store the all details of the product, and this orders table store the order level information. Okay, now, and also we'll create another table is order details, and it is links to the orders and the products. Okay, here order ID, product ID, quantity, primary key, order ID, product ID, foreign key, order ID, that is the primary key of the order tables. Okay, and the product ID references to the product table. So here is the how BCNF we have fixed: customer table, product table, orders, and order details. So below diagram includes all those tables like customer, product, orders, and order details. and all are in the BCNF. Okay, now let's start the database design using the constraint. Okay, so contents, what is the constraint? Constraints are used to give the condition or rules on the table so the valid and the meaningful data can be stored in the tables. Constraints can be given at the column level or at the table level. If one constraint is given for the column in the table, or if two constraints given for one column in the table, then column is it is at the column level constraints. If one constraint is given for the group of columns or two columns in the table, then it is the table level constraints. So syntax for creating constraints, like constraint name. There are different types of constraints like unique, not null, primary key constraint, check constraints. Then foreign key constraints. Uh, the constraints will works only on insert and update commands, and it will not work on the delete commands. So how you can check the constraints? So for this syntax, you can use the sp underscore help constraints, then the table name. If you execute this query, this command in the query editor, you will see all the constraints on the table. You can delete the constraint using alter table command and the drop constraints type of constraints. So unique, there are five types, means unique constraint, not null constraints, primary key constraints, foreign key constraints, check constraint, default constraints. So unique key constraint accepts new unique values, and it allows one null values. Not null accept duplicate values, but it will not accept null values. Primary key constraint is the combination of unique and not null constraints. So primary key constraints accepts only new values and will not accept null values. On a table, we can have only one primary key. In the primary key, two key will be there, that is candidate key and secondary key. Candidate key uniquely identifies each row in the table. If column contains unique values or different values, then it is called as candidate key column. And a table can have multiple candidate key column, but only one can be chosen as the primary key. Secondary key, it uniquely identifies each row in the table when the primary key fails. The foreign key, it is used to create the relationship between tables and maintain the referential data integrity. It is used to create a child or dependent table. Referential data integrity, uh, nothing nothing but the values in the foreign key column of one table refer to the primary key column value in another table. Check constraints, it's ensure that the value in the column meets a specific condition. Default constraints, it using the default constraints we can specify the default value of for the column. Composite key, it will work with the multiple columns in the table. It will works with the composite or mixed data. If primary key is given for two columns in the table, then it is called as the composite primary key. Next is the what is the data types, okay, and what are the data types in SQL Server. There are different data types in SQL servers like integers, characters. Okay, integer has different subtypes like tiny integer, small integer, int, and big int. Characters, characters also divided into different subtypes like char, varchar, in varchar, in char text and text, in text. So here in stands for the national characters set. So char is the fixed length and it always uses the full amount of allocated memory. Varchar is a variable length. It only uses the memory for the character given. It prevents the wastage of memory. Char and varchar uses the ASCII code. Nchar and nvarchar uses the Unicode, okay, which supports multiple languages. Unicode uses 2 bytes per character. Float. Float is also uh, float has float also has the different subtypes like float for floats, decimal, small money. Then binary. It returns. It has the bit values true or false, and also has the image, large objects. Varchar max. Okay. In varchar max. Dead time. It time also has the different subtypes like small dead time, date, and time. Also has the miscellaneous data types like SQL variant, XML table. Can SQL variant stores any type of data. XML is used to store the data in XML format. Table is used to get the records from a table. Operators in the SQL servers. There are different types of operators like arithmetic operator, relational operator, logical operators, spatial operators, concatenation operators. So here now let's create a database practically. Okay, so I'll show you how to create a database using this means using the comma query, and also I'll show you how we can create a database from the object explorer. Okay, let's create first from the object explorer. Here you can create a right click on the new database, and here you can give the database name as empdb. Okay, now it will create uh, two files. One is, yeah, here you can see the mdf file and the log file. Okay, now database is created. Also we can add the secondary file to the existing database. Okay, or we can remove the database using this command. We can drop the database. Here are the SQL command sets which we can use. So the data definition language, it works with the column structure of the data. Those are the create, alter, drop. Data manipulation languages works with the rows and records, and those are the insert, update, delete. Data control language, and these are the grant and revoke. Grant gives the rights to a user, and the revoke removes the rights from a user. Transaction control language, commit and rollback. Commit means it saves changes permanently. Rollback means it cancels the execution of the commands. Means one command fails, then all the commands reverted back. The data retrieval languages is select, which we use to get the records from the table. So here you can see the diagram, the types of DDL, DML, DCL, DQL, and the DCL. So the basic SQL command to view the tables in the current database. Here this is this. Okay, we don't have any tables in this database. Okay, let's switch to the database. Okay, now let's create a table. Emp int alumni. Okay, as of now we can give these two columns. Okay, and we can save table as emp. Okay, now one we have created a table. Here you will get the emp table. Okay, type user defined type id. Okay, so we are in we are in emp db. Okay, and suppose you want to go to the different database abc, then you can use the command like use abc. So it will switch to the abc database and can write a query for that database. Okay, here is the syntax for creating a table. Create table, table name, column name, data type. Okay, so table name and column name should not have spaces, and uh, we can use underscore to join the names, to join the words. Table name or column name should start with the characters. A table name can contain uh, thousands of columns. If you want to see the structure of the table, okay, you can use this command. Let me switch back to the empdb. Okay, now here uh, emp. Okay, here you can see the name of the table. Okay, that is the type, owner type dbo, columns emp id, emp name. It table, this table don't have the identity. Okay, so for inserting records into the table, you can use insert command. Insert into table, table name, values, then value 1, value 2, or insert into the table name, column name, then values and the value. Now I that is the you can insert data using the query. Okay, so now I am going to insert the data using this editor. Okay, so for this you can click on the edit top 200 rows. So emp id is 1, name is Vijay, 2, name is Sanjay, 3, name is no. Okay, so I have inserted the data using the object explorer. Now let me get the data from this table. Okay, so let's start from emp. So here I get the data, employee id, employee name. Okay, To view the records in the table, you can use the select star. Okay, or star means it will gives all the columns, or if you want to see the particular columns, then you can specify the column name from the table name like this. So it gives us all the columns, that is employee ID and employee name. And suppose I want only EMP name, then I'll, so it will gives me the only EMP name. Okay, two, we can delete the table using the drop table command. Okay, drop table name EMP, or you can right click, and if you click on this delete button, it will delete the data, sorry, delete the table, drop table. And if you run the query, then it will give the exception like the inherit object name EMP means table is deleted. So following are the operate clauses and the operators, that is null. It works with the null values. So it replaces the null values with the specified values like operators. It is used with the column containing the characters, okay, or pattern matching. So uh, there are two wide card used in the like operator like underscore. It is used for the single character, and underscore percentage means within we can define a set of characters. In operator is used to specify the multiple values in where clause. Between and at is used to specify the range in like minimum and maximum values. Is used to work with the null values. And order by is used means order by is used to show the records in a ascending or descending order. Okay, here are some advanced statements like to create a duplicate table. Okay, to create a duplicate table, you can use the select star into duplicate table name from the original table. Fetch and offsets. Okay, uh, it is in fetch and offsets are introduced in SQL Server version 2012 plus. So offset is used to skip or ignore a specified number of records, and fetch is used to display specific number of records. Okay, so example, select the last three records from the EMP table. Select star from EMP, order by EM employee number, offset three rows, fetch three rows. Okay, let me create a table. Okay, first let me create a employee table. Again, right click, create. Number, name. Okay, name. Okay, now I am setting, marking this as the primary key column, and also I am adding the identity here. Okay. Now let me add the records into this. When we set the identity, then we are not adding the values for this column. It is automatically incremented by 1 and it is started from the 1. Okay. Now let's uh, see the example of offset and fetch. So display the last 3 records from the MP table. Okay, for that we are going to use the fetch and offset. So it will display the 4, 5, 6. Okay. Then group by statements. Group by statement is used to group the similar values or duplicate values existing in the table. With the group by statement, group or aggregate function are used like sum, average, max, mean, count. Here is the syntax. Select ename from emp. Here I don't have any duplicate records in the table, so that's why it gives us the unique values. Now group by extension with rollup and with cube. So with rollup is used to display the subtotals and a grand total based on the first column in the group by statement. Okay, here is the example of the group with rollup. So we don't have this. Okay. Number, name, sum of salary. What is the salary? Top, group by. Okay, this is giving us a result like this. Now with the cube, it is used to display the subtotals and the grand totals based on the multiple columns given in the group by statements. Here is the example. Okay, same with cube. Okay, here it gives the records using the queue. Alter commands. Okay, so alter command is works with the columns, and it is used to modify the definition or structure of the table columns. Here is the syntax. Okay, add column name. Suppose I want to add department column. Anywhere I can. Okay, column is created, so we can check here. The department is name. Department name is null. Add is used to add a new column or constraints. Alter column is used to change the data type and size of existing columns, and drop is used to delete the column or constraint. To change the data type and size of existing columns in the table, here is the syntax. Alter table name, alter column name, then the data type, new size. To see the definition of the columns in the table, okay, so it sp underscore help, then table name. Let's see this. It gives all the details about the table. To delete a column, we can use the alter table name, then the drop column and column name. Okay, to change the column name, so this is the we can use the sp underscore rename, then the table name dot old column name with the new column name. Here is the example. Update. Okay, so update command is used to modify the content existing in the table and used to perform the calculations. It works with the rows and the records. Here is the syntax. Okay, suppose I want to update the salary. Okay, department name. To IT for employee 1. So here is one row affected, and if we run this query, the department is updated. Okay, here computed tables calculate can be created. Okay, like create table employee name, so employee id, employee name, employee number, employee name, basic, ta. These are the columns of the table. Delete command, so delete is used to delete table, okay, or the column. To delete the duplicate records from the table, you can to you can perform the 3 steps. Okay, you need to do the 3 steps. The first is create a duplicate table. to store only unique value, to store the unique records. Okay, for that you can use this syntax: select distinct star into duplicate table name from the original table name. Then you can delete table which contains the duplicate records. For the deleting table, you can use the command, and after that, lastly, you can rename the duplicate table with the original name. For this, you can use this. So truncate command is used to delete all the records in the existing table. Okay, truncate table name. So the difference between the delete and truncate is delete can remove one or multiple or all the records based on a where condition. Truncate removes all the records. Delete and truncate command will delete only the records from the table, but the column name will exist in the table. Rollback can be used with the both delete and truncate. Delete command will delete all the records in the table, but the identity will be reset. Identity will not reset. To reset the identity, tbcc command should be used. Truncate command will delete all the records from the table and will reset the identity. When new records are given in the table, it will start with the initial value or starting value. So for viewing the columns or record using the wizard, you can go to the view, right click on Explorer, double click on the database, rename, database name, tables, right click on the table name and edit top to 100. Same like this. Here is the employee table name and click on the top to 100 records. So you can see all the data in that particular table. So identity is nothing but it is used to generate the numbers in the sequential order, and those values can be used while inserting new records into the table. So here is the syntax: identity, the initial value or the seed value, and then the increment value. So for this table we have added the identity using this wizard. Okay, to see the current identity. So if you want to see the identity on the table, you can use this command like here is the 6, means we have 5 records, 6 records. If you want to reset the identity, you can use this syntax. Okay, from 10, reset value is 1 and the value, new value is 10. Okay, now identity is oh sorry. Okay, now current identity value is 6. Okay, let's add the record into this EMP table. Okay, let's go to this, uh, edit to 100. Now add Rahul, salary is 50,000, sorry 5,000, department is IT. Now it's the seed value is reset to 11. Okay, identity is reset to 11. So to disable identity, you can use the syntax. Here is the table name. It is used to disable the identity, and to enable identity you can use the syntax. Okay, now sequence. So the sequence object is introduced in SQL Server 2012. So it is used to generate the numbers in sequential order, and those values can be used in a table while adding records or inserting a record. So it is used to work on the drawback of identity. A sequence is a separate object and can be used with the existing table. Identity cannot be can be used while creating the table, but cannot used with the existing table. With the sequence object, it will create it will be created first and will be used in the table while adding records. A table can work with the multiple sequence objects. So here is the syntax to create a sequence. Let's go this. Okay, I'll give this as my sequence. Start with value 100, increment by 1, minimum value is 100. So this 100. Okay, now sequence is created. My sequence is created. Okay, let's see. So, means now there is two options, that is cycle and cache. Cycle means when the sequence reaches to the end, max value, then it will start with the beginning values. Okay, by default sequence will access values from the database, and this will with this execution performance will be reduced. By using cache, the sequence object values will be stored in the cache memory or a temporary memory. So now we can create a table. Okay, the table is created. Now we can add the records. Okay, row is created. Let's check. value is added. Okay, so here we haven't set the identity, we use the sequence. So you want to see the sequence in the current database. For this you can use this syntax. So it gives all the sequences. So to modify sequence you can use the syntax, and to delete sequence you can use the drop sequence name. Okay, constraints. So example of constraints, we can use the parent child table. So here is the department table. You can create this. Okay, now we can create a child table. Okay, department is created and EMP department is created. Okay, so here department number is primary key, and in the department table department name number is foreign key, and that is referencing to the department tables department ID, department number. So to add constraint to an existing table, you can use the syntax. Okay, here is table name like DP. No, can use this EMP. Constraint name something like, we can keep this as name, on column name EMP. Okay, so using the syntax we can add a constraint to the existing table EMP. Here is the foreign add the foreign key constraints. Here we have added the foreign key references. Here the table level constraints. Okay, let's create a table using the syntax. Okay, table name e number EMP name, constraints primary key, e name and e number and e name. Okay, for subqueries. Subquery is a query within another query is called as subquery. So means let's check practic in the real time how we can use the subqueries. So write a query to get the second highest salary from the EMP table. So for this we can use this syntax. Okay, max salary. So here 20,000 is the second max salary. Okay, you can check 30,000. Okay, this is the highest salary, then the second highest salary. Now uh, we can take another example, like write a query to get the nth highest salary. In our case we can get the fourth highest salary. So for that you can use this syntax. So you can check the first one, second one, third one, and this is the fourth one, highest salary. So you will get this result using the subquery. Now the nested subquery. So nested subqueries are the query within another subquery is called as nested subquery. So nested subquery contains three select statements, and they are main query, subquery, and the nested query. So let's see the real-time example of this. To get this, to get the write a query to get the third highest salary. Okay, so for this we can use this syntax. So main query is this. This is this is the first select statement, second and third. So if you run all this, okay, here salary is not called. Okay, we have salary column. This is the third highest salary. You can check using this, the first highest, second highest, and third highest salary. It will gives us the third highest salary. Now another most important question asked in interview is this: write a query to get the second highest salary. So for this you can use the syntax. This is the second highest salary for the employee Sanjay. So in the correlated subqueries, main query will execute first, then the value of that main query will be used for the correlated subqueries. When main query is executed, then the copy of that the table will be stored in the memory. Here is the example. Write a query to get the details of employee with the first highest salary. Okay, let's check in the real time. So this means we have created the employee table yet. So let's first create the employee table. Okay, now so this is the sub so you can see here in the emp1 table we have three records, and when we use sub correlated query, then it gives us the first high salary of 60,000. So if there is any number like 0, 1, 2 are present in where clause, then it is correlated subquery. Set operators in SQL Server. So set operator will work on multiple tables. Set operators are used to join the result of two select statements, two or more select statements. It will show two result as one result. Set operators are used to join rows or records of different tables, whereas joins are used to join columns of different tables. So there are different types of set operators in Server, and those are union, union all, intersect, and except. So union is used to display unique values from both the tables, and it will remove the duplicate entries if both queries return new arc. For example, if both queries return the new arc, then only one new arc will be appear in the result. So in union all, it will shows the values from both the queries including duplicate values. It is faster than union because SQL Server doesn't perform the distinct sort. If both queries return new arc, it appears twice, means the duplicate records. Intersects. Uh, it will display similar values existing in the both the tables. Only cities that appears in the both tables are returns. It automatically removes the duplicate records. So except displays the value from the first table which are not existing in the second table. So it shows cities that are in customer but not in supplier tables. It also removes the duplicate records. So let's see the practical example of union, union all, intersect, and excepts. So for this, first we need to create the table customer and the suppliers. Okay, let's have a practical look. So now I have created the customer and supplier table. Let's insert data into those. Okay, we have created the customer and the suppliers tables. Let's execute the select query on both. Let's see the records. Now let's have the real-time example of the union. First, check the records of customer and supplier tables. So this shows the customer's records and this shows the supplier's records. Now, if when we apply union on the customer and supplier tables, then it gives us result as Boston, Chicago, Dallas, New York, and the settle, because it removes the duplicate records. Now let's have the example of union all. Let's execute. So you can check here New York, Chicago, Dallas, New York. In the customer we have duplicate records. In the suppliers we don't have the duplicate records. But when you see the union all, you will see the New York, Chicago, Dallas, New York, means New York and Chicago are the duplicate entries in the result of union all. Now let's have the real-time example of customers, real-time example of intersect. So intersect will display the same record from both the tables. Here Chicago, Chicago. Now let's have the real-time example of except. Okay, so in the first table we have Dallas, we have Chicago, we have New York. But in the second table we have Chicago, Boston and Seattle. So it will gives us the records from the first table that is not exist in the second table, that is Dallas and the New York. So what are the conditions uh, or the rules for using the set operators? So each select statement must have the same number of columns. Columns must be in the same order. Data type in corresponding column must be compatible, that is int with numeric, char with varchar. Order by can appear only once at the end of the combined query. Here is the set operator continuation. Here is the table. So it gives the difference between union, union all, intersect and except. So this is the Venn diagram of showing how each SQL Server set operator works. Here is the union, means combines the result from both the queries, union all, then intersect and the except. Now merge statement. So merge statement is used to add records of one table in another table. Based on the common column names, records can be merged in another table. It work with the update and insert command. If matched value are existing, then update command will work, and if matched value are not there, then inserting command will work. Here is the syntax of the merge statement. Merge into source table using destination table on condition. When matched, then update command. When not matched, then insert command. Here is the example of merge statement. Let's have real-time example of merge statement. Now, first, let's check EMP1. Here, the Dana, UN, and Fair are added in the EMP1 table, and Dana, UN, Fair updated in the EMP2 table. Now, joins. Joins are used to show multiple tables as one table. Joins are used to join columns of different tables. There are different types of joins, that is inner join, outer join, cross join or Cartesian join. So let's started with the inner join. So while joining the tables, if the tables are having matched records or related records, then inner joins are used. There are two types of the inner joins, the equijoin and the self joins. So in equijoins, table can be joined by using the equals to symbols. So we can have the real-time example of the equijoins. So before starting the equivalence, let's create a department table and add the records into department table. Let's check. Okay, we have 4 records. Now let's uh, have the real-time example of equijoins. Okay, here the this is the result of employee 1 table, this is the result of department table, and this is the result of equijoin. So equijoin can also be called as the natural join. For joining the tables, column names can be a same or column name can be a different, but the values in the column should be the same. Now self join. So a table can be joined to itself if different columns in the table contain the similar values, then self join is used. Let's see the real-time example of the self join. So before having the real-time example of self join, let's create employee table. Okay, and now let's add values into the employee table. Let's check values of the employee table. Okay, now let's have the real-time example of self join. So in self join, we are performing self join based on the manager ID and the employee ID. So here is the result of the self join. Now the second join type is the outer join. So while joining the tables, if the tables are not having matched records or related records, then outer joins are used. There are different types of outer joins, which are the left outer join, right outer join, and the full outer join. So left outer join, it will take all the records from the first table and will join with the matching record of the second table. So let's have the real-time example of left outer join. First, let's create a table, EMP department. Let's check the values of the EMP department. Here is the values. Now also check the values of department table. Okay, HR. Here in the department we have the HR department, finance, IT department, and marketing. But in the EMP department we have HR, finance, and the IT departments. Okay, let's have the real-time example of the left outer join. Now here it will returns all the means all the records from the department table and the matching record from the EMP department table. Now let's have a look at the outer join. So outer join, it will take all the records from the second table and will join with the first table. Let's see the practical example of the right outer join. Here it is the result of the right outer join. Now let's have a look on the full outer join. So it is the combination of left outer join and the right outer join. It is used to display all the records from both the tables. Let's have the real-time example of full outer join. So here is the result of full outer join. And the next type is cross join or Cartesian join. So in this, each record for the first table will join with all the records in the second table. Here is the real-time example of this. So it gives us 12 record because in the first table we have 4 records and in the second table, that is EMPDP, we have 3 records. So it multiplies and gives us the 12 records. And here is the visual Venn diagram of different types of SQL Server joins. Now views. View is a logical table used to display required information from the table. View will be created by using select statements. View will not store any values and will not use memory. In view, physical data will not be stored. There are 4 types of views. Those are simple view, complex view, indexed or materialized view, and the partitioned view. So let's have a look on one each view type. So the first is simple view. So simple view is created by using the select statement with where condition. When we create a view on a single table, then it is called a simple view. So here is the real-time example of same simple view. So before starting with the real-time example, let's create a table employee. Let's me drop let me drop this and then the create, and let me insert the values. Okay, now let me check values, the employee table. Okay, 1 2 3 4. Let me create a simple view. Okay, I have created the simple view, and let me get the data from this simple view. So this view employee gives us the all the employees which having the department as IT. So here you can check, we have Bob and Ram whose department is IT. In simple view, we can insert, update and delete data. We can only insert data in simple view if we have primary key and all not null fields in the view. So let's have the real-time example of insert, update and delete records from the view. So let me first insert the record. Okay, now let me check whether the record is inserted or not using the view. So now it gives me three records because the third one record is added. Now let me update the record, means let me update the records using the simple view. Here is the view name. I'm updating the name of employee to Raj, whose employee ID is 104, means Ram. So now the Ram is updated with the Raj. Now let's uh, perform the delete using the view. Now let's check whether the employee ID 105 is deleted or not. So it's not giving 105, means that record is deleted. So in this way we can perform the insert, update, delete using the simple view. The second is the complex view. So complex view is created with one select statement having order by or group by or else by using joins. When we create a view on more than one table, it is called as complex view. Here is the real-time example of the complex view. Here is the example 1. Now I have created the view which gives me a top 3 employees. Okay, let's check the employees. Now we have 4 employees. Okay, now okay, so it gives us the top 3 employees by order by salary descending. So first is 60,000, 55,000 and 52,000. Now we can only update data in a complex view. We can't insert data into the complex view. Yeah, okay. So before that, we have second example of the complex view. Let's have a look into that. Now I have created the second view, that is view empty dpt. Now let's check what it returns. So it will gives us the records. So to see views in the current database, we can use this syntax. So it gives us 3 views, that is the view employee, view top 3 employee and the view emp department info. To delete view, we can use this syntax. So I want to delete the first one, simple view. Okay. So drop view and the view name. Now view is deleted. Let's check whether the view is deleted or not. So that view was deleted and it gives us only two records. So here is some note, some points that needs that keep in mind. We make views for a security purpose since it restricts the user to view some columns fields of the tables. One more advantage of view is data abstraction since the end user is not aware of all the data present in the database table. Want to use queries without rewriting them and need a consistent data structure for reporting or applications. Here is the syntax that we have already done. Now, the next type is indexed view or materialized view. If index is created on the view, then it is called as materialized view and it will not show the records in ascending or descending order, but faster access of data will be there. Physically stores the query result in the database and performance useful for aggregation heavy queries requires with schema binding. Let's have real-time example. Okay, here is the real-time yes, example of indexed view. Let me create a view. So view is created. Let's check the result of this view. It gives us the result. Okay, now let's check whether view is created or not. Here is it gives us three records, means view is created. Here is one point that we need to keep in mind, that is after schema binding no modification can be done on existing columns, meaning after schema binding you cannot change this column in the employee table until the view is dropped. So to check the schema binding we can use this syntax. Let's check in real time. Okay, here, sorry, my bad. Here it gives the result. Here is the syntax. To create an index on the view, that is create unique clustered index, that is the index name on the view name, and here is the column name. The last one is partitioned view. So partition views combines the data from multiple tables, usually in different database or servers, using union all, often used for large data sets. Here is the real-time syntax of partitions view. Let's create this table. Now let's create another table. Okay, we have created two tables and we haven't inserted any values into the table. Let's insert the values. Now we have added the values into the employee 2024 and the employee 2023 tables. Now let's create a view partition. Now let's create a partition view. Now check the view is returning value or not. So it's returning the value, correct values. Okay, so next is the indexes. So indexes will be created on a table so that the records in the table can be accessed quickly, and the records will be displayed in ascending or descending order. With the index, table execution performance will be increased. Index in SQL Server works automatically. Index can be created automatically or manually. Automatically means with the primary key constraints, cluster index will be created. With the unique constraints, non-cluster index will be created manually. Manually means user can add index for the required column in the tables. So here is the syntax to create the index. Let's create the index in the real time. Now I am creating a non-cluster index on the column department. Okay, so index is created. There are two types of index. One is the cluster index and non-cluster index. So let's have a look on the cluster indexed. So based on the index column, the records in the table will be physically rearranged. A table can contains only one cluster index. In a cluster index, the data itself is sorted and stored in the order of the index column. Example, table employee clustered indexed on the employee ID, physical storage on disk clustered index on the employee ID. Okay, here is the example. Now, so what happens here? The rows are physically arranged on the disk by employee ID. The cluster indexed and the data are stored together. There is no separate structure. This makes searching by employee ID very fast. The non-cluster indexed. A table can contain 249 non-clustered indexes. It will not change the physical order of orders in the table, but with the help of index, data can be accessed quickly and records will show in ascending or descending orders. In a non-clustered index, the data stays in its original order, and a separate index structure is created that points to the data rows. Example, employee table non-clustered index on the employee name. Okay, here you can have a look how non-clustered index stored separately, employee name, pointer, and rows address. So here is the John pointing to the second row. Okay, the Bob is at the row 4, the David as row 3, Ram is at row 1. So what happens here? The data, the table data's physically order does not change. The non-cluster index store a sorted list of employee name values with a pointer to the actual data rows. This helps SQL Server find matching rows quickly without searching the whole table. Here is the syntax to create an index. Create unique cluster non-cluster index name on table name, column name, and the ascending or descending. So this syntax is used to drop this index. So let's drop index in real time. Okay, so we have created index on the table employee. Now let's drop that, and now we have dropped that index. To check the indexes with the constraints, uh, let's have example. Okay, it's already exists, so let me first drop, or let's create a new table, that is employee 10. Okay, now we have created indexes with, means we have created a table. Now we can check the constants using the syntax. Here is the primary key constants. Non-clustered index, the result of that sp underscore help constraints. Example, using cluster index, create cluster index my index on emp1. Here is the example. Okay, now we are going to create it on the employee emp table 10. Let's create first. Okay, because we have already created a primary key constant. We haven't inserted the records, and here is the syntax of deleting the index, drop index table name dot index name. And here is the example of a non-clustered index. So create non-cluster index name on table name, then the column name, and here is the select statement and the drop statement. So we can work with multiple non-clustered index. Here is the syntax. So create non-clustered index my index 4 on emp4, include ename and salary. Ename and salary are the columns. Okay, also we can create another non-clustered index my index 5 on emp4 on the column salary includes ename and ename and enumber. So here is the select statement. Select star from emp4 where e number greater than 101 and the select star from emp where salary greater than 1000. So it will return us the e number in ascending order and the salary will be in the ascending order. So some points that we need to keep in mind: if a table contains the multiple non-clustered index, then two conditions should be satisfied. Those are select statement should have a where clause and index column should be given in where clause. Clustered and non-clustered indexes can be non-unique or unique indexes, and the default is non-unique. If the index is a non-unique, then it will work on the column containing duplicate values. If the index is unique index, then it will work with column containing unique or different values. So to view indexes created on table, click on View Object Explorer. So let's check in real time. View Object Explorer, Database. Here is the view, and you can see the view, all the views created. Okay, to view indexes created on the table, okay, double click on database name, tables. Okay, here is the table. Suppose let's go into the table and check the employee. Expand that. Here you can see the indexes. The next one is the pivot. So pivot is used to display the values in crosstab or matrix format. If table contains duplicate values, then the without duplicate value to display the result set pivot option is used. The value in the table will be used as a row heading and column heading. Pivot is used when we want to transfer data from one row level to column level, and unpivot is used when we want to convert data from column level to row level. Here is the syntax of pivot. Select a non-pivot column, list of pivot column from select query to produce the data as well as name pivot, aggregate function column name for column name that become column headers in list of pivoted columns as alias name for the pivot column. So let's create a cells input table, and here is the example of that. Select start from cells info pivot sum of cells in the year to 2022 and 23A. Note: cells and year means column name and A means temporary column, likely intended to mean alias or the temporary tables. Let's have this. Let's have look this in real time. So let's create a cells input table. Okay. Now let's add some values. Now let's create a pivot. Now have let's have the means let's have the result of pivot. Okay, so first is the result of cells input table, and this is the result of the pivot. So here Ford is in year 2023. Okay, and the Toyota and the Honda is in year 2022. So it gives the Honda and the Toyotas that is in year 2022, and we don't have any uh, sales info for the year 2013. Now let's have a look on the common table expression, which is the table CTE, and CTE is used to give temporary name or alias name for the query or the select statement. So here is the syntax for that: with CTE name, column names as query select statement and select start from the CTE name. So let's have the CTE in real time. Okay, employee ID, employee ID, employee name, department, and the salary. Okay, as select star from employee where salary greater than 10,000, select star from CTE. So it gives us the records having salary greater than 10,000. Let's change the condition. Okay, and now let's check. So it gives us only two rows. What are the system or built-in function in SQL Server? SQL Server provides different system or built-in functions that perform specific operations and return a value. This function can be used in select clause or where clause or any SQL expressions. So following are the system functions in the SQL Server. The numeric functions, string functions, aggregate functions, date functions, conversion functions, and the ranking functions. Let's see one by one in detail with real-time example. So first we'll discuss the numeric function in SQL servers. So the numeric functions are used to perform the mathematical operations, or it returns numeric results based on the given input values. So again, the numeric function is divided again. So and those functions are ABS, length, round, ceiling, and the floor. So let's have discussion about the absolute ABS functions. So ABS functions returns the absolute, the positive value of the number. So example here is select ABS minus 14. So it returns 14, positive 14s, and the ABS function removes the negative sign and returns the positive equivalents. Let's check in the real time. Let me open this Microsoft SQL Server Management Studio and run this query. So it gives me a 40, that is positive 40. Okay. Now let's discuss the next numeric function, that is length. So alien is used to means it gives the length of the given strings. Here is the example, that is select length Vijay. It gives the length of 5, and the length function is function counts the number of characters in the string excluding the trailing space. Let's check in real time. Okay, so here is the mistake. It gives us 5 as length. Now we can discuss the next numeric function, that is the round. So round is a numeric function. Round is a numeric value to a specified number of decimal places. So here is the syntax: round the number and the decimal places. Example, select round 60.6789 and the decimal place is 2. So it gives us 65.68. So here the number is rounded to the two decimal places. Okay, let's check in real time. So it gives us 6800. Now we'll discuss the next numeric function, that is selling. So it rounds a number to the nearest integer value. Example here is select selling 15.67. So it gives us the 16. So selling is always rounds up regardless of the decimal value. Let's check in real time. So here it gives us a 16. So the next numeric function is the floor. So floor rounds a numeric number down to the nearest integer value. Example is select floor 15.67. So it gives us the 15 as a result, and it always round down ignoring the decimal part even if greater than 0.5. Let's check in real time. So it gives us the 15. Now the next SQL built-in function is string. So string functions are used to perform operation on a text data such as formatting, searching, trimming, or transforming strings. So they are very useful for cleaning data, comparing text, or preparing outputs. So following are the types of string functions in SQL servers, and those are lower, upper, ltrim, rtrim, length, substring, replace, concat, reverse, char index, left, right, space, ASCII, replicate, soundex, and the difference. So let's discuss one by one in details. So first is the lower. So the purpose of the lower function is it converts all the characters in a string to a lowercase. Example is select lower hello world. So it converts all the string hello world to the lower characters. Let's check in real time. So it gives us uh, the hello world in lowercase. Now the next string function is upper. So upper converts all the characters in a string to the uppercase. So here is example is select upper SQL Server. Okay, and it gives us the SQL Server kept in uppercase. So let's check that in real time. So we pass SQL Server as lowercase, and it gives us the SQL Server in uppercase. So next string function is ltrim. So ltrim removes the space from the left side of the string. Here is example of select ltrim space hello. Then it removes the space from the left side. Let's check it in real time. So I have added the multiple spaces before the hello. Now when I execute this, it gives me a hello without any space in left side. So next string function is the rtrim. The rtrim is used to remove the space from the right side of a string. Here is an example. Select rtrim. In that we pass the hello as a string, and after that we pass the multiple spaces, and it gives us the result as hello without space in the right side. Okay, let's check in real time. So I have added here multiple space. So it removes all the spaces from the right side. So next string function is the length. So uh, length is used to return the number of characters in a string, excluding it excludes the trailing spaces. So here is the example. Select length database and it gives us value as 8. Let's check it in real time. Okay, it gives us the length of string as 8. Now, so the next string function is substrings. So substring extracts the part of a string from the given position. Here is the syntax: substrings expression, start position, and the length. So here is the example: select substring SQL Server 1, 3. Okay, and it gives the result as SQL. Okay, so, it take the character start from S to the 3, 1, 2, 3. That means till the L. Okay, and after that it skips. The next string function is replace. So replace, it used to replaces all the occurrences of a substring with another string. Here is example of select replace I love SQL with SQL and the databases. Okay, so it gives us the result as I love databases. Let's check this in real time. So here SQL is getting replaced with the databases. Okay, so it gives us I love databases. So next string function is concat. So it combines two or more string into one. Here is the example: select concat SQL string 1 comma string 2. Okay, let's check this in real time. Here we are concatenating the SQL and SQL Server, so it gives us result as SQL Server. So next string function is the reverse. So it returns the reverse of a string. Here is example of select a reverse SQL. So it returns LQS. Let's check this in real time as well. So it gives us the reverse string. Now the next string function is char index. So it returns the position of a substring in a string. So here is an example: select char index a comma database. So it gives us 2. Okay, let's let's check in real time. Here it returns 2. Now the next string function is the left. So left returns a specified number of characters from the left side of a string. So here is the example of the left. Select left database comma 4. So it gives us a data. Let's check this in real time. So one data. Now the next string function is write. So it returns the specified number of characters from the right side of a string. Here is an example of select write database 4. So it gives a result as base. Let's check. Here is the base. Now the next string function is space, and it returns a string of spaces of a specified length. Here is an example of select SQL plus space of 3 plus SQL plus server. So it gives us SQL 3 space and then server. Let's check this in real time. Okay, here you can see the space. Now the next string function is SQL server. Server is ASCII. So ASCII returns the ASCII numeric value of the first character in a string. Select ASCII A. So it gives us 65. So let's check this in real time. Here is the 65 ASCII value of A. Now the next string function is replicate. The replicate repeats a string a specified number of times. Replicate string integer. Here is the syntax, and the example is select replicate SQL 3, means it returns SQL as 3 times. Let's check in real time. So it returns SQL 3 times. If I change it to 2, then it returns SQL 2 times. Now the next string function is soundx. So soundx returns a phonetic code representing how a string sounds when spoken in English. Here is an example. Select soundx Smith. So it returns both returns S553. Let's check in real time. So here is the response. Now the last string function is the difference. So it compares two strings based on their soundx value and returns a number 0 to 4. Select difference Smith. So it gives a result as 4, similar, very similar. Let's check in real time. Okay, the higher the number, the more similar the word sounds. 4, strong match. Now let's discuss the next built-in function in SQL Server is aggregate or group functions. So the aggregate or group functions are used to perform calculation on multiple rows of a table and return a single summary value. So they are typically used with a group by clause when summarizing data. So following are the aggregate function in SQL servers, and those are sum, average, max, mean, count. Let's discuss one by one in details. The first aggregate function is sum. So it returns the total of numeric column values. Example, select sum of column name is salary as total salary from employee. Let's check in real time. Okay, so here is the total salary is 85,900. So let's check the value from the employee table. So here is this value. It gives us, if I use the sum, then it gives us the total as 85,900. Now the next aggregate function in SQL Server is average. So it returns the average mean of numeric values. So here is example is average, select average salary as average salary from EMP. So let's check in real time. So the average salary is 10,737.5. The next aggregate function is max. So it returns the maximum or the highest value in the column. So let's check uh, the max in real time. So let's check these two. So max is 30. Here is 30, the max salary. So next aggregate function is min. So it returns the minimum or the lowest value in the column. Let's check in real time. So here is lower salary is 3950 and it gives us the 3950. Now the next aggregate function is count. So it returns the number of rows that match a specified condition. Here is an example. Select count star as employee count from EMP. Let's check in real time. So here is, it has 8 rows and it gives us employee count as 8. Now the next built-in function is SQL is date function. Date functions are used to perform operation on date and time values. They allow you to retrieve, modify or calculate with the dates in the SQL Server. And following are the date types in SQL Server, and those are get date, date path, date add, date difference, date name. So let's check these date function one by one. So first one is the get date. So it returns the current system date and time. Let's check in real time. So it gives us the current date 31st of October 2025 and this is the time. Okay. Now the next date function is date part. So it returns a specific part of a given date, such as year, month, day, or hours. Here is the syntax, that is date part, part and date. So here is the example. Select date part, hour and get date. Let's check this in real time. It gives us 0. Now, so you can extract the different parts of a date using keywords like Y for year, CM for months, DD for day, HS for hour, MI for minute. Okay. So next date function is date add. So it adds or subtract a specific time interval, that is days, months, years to a date. So here is the syntax, date add interval number and date. So select date add day by 1 and the get date. Let's check in real time. So so it will add 1 day to the current get date, current date. Okay. So today is 31st of October, and if we add 1 day here, so it gives us the 1st of November with the time stamp. The next date function is date difference. So it returns the difference between two dates in the specified interval, that is year, months, days, etc. Here is the syntax, date difference interval start date end date. So let's check this in real time. So it calculates the number of years between each employee. We can also add day, days, months for the interval. Uh, we don't have this column, okay, in our table. So first first add this is the part. So you can you can calculate the date difference using the date difference functions. This is for you. Okay. Now let's move to the next date function, that is date name. So it returns the name of a specific part of a date, such as the month or week, date name, date part name, date. So let's check this in a real time example. So it gives us the month of October. So the next conversion function is the next built-in function in SQL Server is the conversion functions. So the conversion functions are used to change the data type or a format of a value. They are commonly used to convert numbers, dates, or other data types into strings or the vice versa. Following are the conversions function in SQL Server, and those are convert and cast. So Let's discuss these functions in a details. The first is the convert. So the convert function is used to convert a value from one data type to another type with an optional style parameter for formatting, especially useful for the dates. So syntax is convert, target data type, expression, and the styles. Let's have let's check this in real time. So it gives us the conversion. Okay, so it converts get date to the varchar. Okay, so here is some explanation is that the first argument varchar 25 defines the output data type and the size. The second argument get date is the expression being converted, and the third argument the style code controls the display format. So some common data type codes are the code style, a style code, format, example, and the description. Style codes are 100, 101, 103, 106, 108, 109. Here is the format. Okay. Monday, DD, YY, HH, MI, AM. These are the common used style codes. So the next conversion function is the cast. So it converts a value from one data type to another without using style codes. It is ANSI standard and supported across different databases. So here is the syntax cast expression as target data type. So here is the example. Let's check this in real time. So it casts the current get date to this format. The next built-in function is ranking function. So the ranking functions are used to assign a rank or a sequential number to each row in a result set based on a specified order. They are especially useful for analytical queries such as finding the top n result or handling duplicates. All ranking functions requires the use of the over clause with an order by statement and optionally a partition by clause. Following are the ranking function in SQL servers, and those are the row number, rank, and dense rank. So let's discuss this in details. The first one is the row number, and it is introduced in SQL Server 2005. And the purpose of row number is it assigns a unique sequential number to each row starting from 1. The numbering restarts when the new partition is encountered. So here is the syntax: row number over order by column name, or row number over partition by column name, order by column name. Here is the example of the row number. Let's check this in real time. Okay, so it gives row ID 1 2 3 4 5 6 7. So it assigns a sequential number based on the number order. If you use partition by department name, the numbering restart for each department. So let's check the partition by column name example. Let me close this tab. Okay, here is the syntax. Okay, here is the select query using partition by. Here we have used the department name, means partition by department, so it For these employees, we don't have the department name, so it returns null, and its order is 1 2 3 4 5. And when we get the department, then its order is reset and it starts with 1, and in this way it continues. The common use case is it used for deleting the duplicate rows while keeping one instance. Okay. So next ranking function is rank. It is also introduced in SQL Server 2005. It assigns a rank to each row based on the order specified. If two rows have the same value, they receive the same rank, and the next rank is skipped. So here is the syntax: rank over order by column name, and here is the example. So let's check this in real time. Let me remove this. So before that, let's check value of, means let's get the value of EMP table. Okay, here is the value, right? Now this query gives us the rank. The first two, John and Ajay, have the same salary, so it gives us rank 1 1. So it skip the second rank and it continue with the third rank. Okay, so both John and Ajay share the same rank 1. The next rank 2 is skipped, so Rahul gets rank 3. Now the third ranking function is the dense rank, and it is also introduced in SQL Server 2005, and it works like a rank but does not skip the next rank number when there is a tie. Dense rank over order by column name, and here is the example. Let's check this in a real time. Here is the 1 2 3 4 5 6 7 7 order by salary. We can just remove this descending. So John and Ajay has same rank, that is 1, and it continues with the 2 3 4 5 6 7. Unlike rank, the next rank is not skipped. After the tie at rank 1, the next row continues with rank 2. What is the PLSQL TSQL programming in SQL Server? Uh, in SQL Server, we call it as TSQL Transact SQL, but the concept is same as the Oracle's PLSQL. It means you are not just writing individual SQL statements, you are writing procedural code, variables, conditions, loops, and the logic that makes SQL behave more like a traditional programming languages. PL means procedural languages. PLSQL is the code block or collection of statements that will perform a specific task when it is executed. A code block is a collection of SQL statements and the control logic that execute together. It's what you use inside store procedure, function, or script to add a logic beyond the simple queries. So in PLSQL, you declare a variable. Here is the syntax for declare variable name, then the data type and size. So we can assign the values to the variable using the select variable name equals to value, and we can print value using the print then the variable names. So here one note is that SQL Server contains local and global variables. Local variable can be used within the program, and global variables can be used anywhere in the database. Local variable contains the single asterisk symbols at the rate symbol, and the global variable contains double at the rate symbols. So let's see this in a real time. So here is the variable name is name, then the uh, type is varchar 50. Okay, now we can assign value to the name. Okay, and now we can print the name. So let's execute this. So it will print the variable value is Vijay. Now in SQL Server, you control logic inside queries and the script using the conditional statements and loops. There are three common ones are if, case, and while loops. So let's discuss these in one by one. If conditions. So it is used in TSQL script and stored procedures to run the code only when a condition is true. Here is the syntax for that. If conditions is true, then statements. Else if condition true, then statements. Else statements. Here is the example. Declare marks as integer. Select marks equals to 85 if marks greater than 90, print grade A. Else if marks greater than equal to 75, print grade B. Else print grade C. Okay, let's check this in real time. So here I'm assigning value to marks as 85. Let's execute this. So it prints grade B because we have passed marks as 85. Now pass this as 91. Okay. Now it prints grade A. Now pass value as 55. So it prints value as grade C. Now the second one is case. So case is used inside a query to return a different values based on a condition. It is an expression, not a control flow command. Okay. Here is the syntax. Case when conditions true, then statements. When condition, then statements. Else statements. Here is the real-time example. Okay. Let's see this in real time. Now, let's change database to the EMP database. Okay. Okay, here is the salary range. Okay, now we are using the case statement here. Select name salary case when salary greater than 15,000, then it print high. When salary between 8,000 to 14,999, then it medium. Else it low. It prints low. Okay. So before that, it let's check the salaries of the employees. Okay. Here now execute both. So it's clears your doubt. Okay. So Vijay employee has salary of 10,000. Okay. So it's in the range, means it is in between 8,000 to 14,999. So it will print medium. Is the 20,000? It prints high. 30,000. It also print high. And the salary is uh, 3,950. Then it prints low. Okay. So case statements works like a switch or inline if in other languages. Now the third one is the while loop. So while loop, it creates a loop in TSQL script and stored procedure. The code runs while the condition remains true. Here is the syntax: while condition begins, then statement, then end. Let's check this in real time. Now I am, means I have declared a variable I and assigned the value to the 1. Okay. While I is less than equal to 5, then it will print I, and then it also reset the value I to I plus 1. Okay, let's execute this one. So it will print 1 to 5. Okay. Now uh, a while loop repeats code until condition changes. In PLSQL we have only one loop, and that is the while loop. So stored procedure is a pre-compiled block of TSQL statements that can accept parameters, perform actions, and the actions like insert, update, delete, read, calculation, and may or may not return a result. You can think of it's a method or function in other programmings stored permanently in the database. A stored procedure is a prepared SQL code that you can save so the code can be reused over and over again. Here is a syntax to create a stored procedure. So the create procedure name as begin statements. So let's create a stored procedure in real time. So here we are creating a stored procedure with the name get all employees. Okay, now the stored procedure is created. Now we can execute stored procedure. So it gives us the result of the employee. Okay, so the stored procedure is the precompiled and stored in the database. You execute it with exec or execute keywords. Okay, so stored procedure with parameters. You can make your stored procedure more flexible by using the parameters. Okay, let's uh, create another stored procedure with the parameters. Okay, now uh, I am creating a stored procedure which returns the employee by department name. Okay, so I have created a stored procedure, and now I'm executing this stored procedure and passing the department name. Okay, as IT. So it gives the result. It gives all the employees that belong to the department IT. Okay, let's verify. Okay, so Vijay, Rahul, and Ajay are in IT departments. Okay, let's confirm whether our stored procedure is returning the employees that belongs to the IT department or not. Okay, so Ajay, Rahul, Vijay, Rahul, and Ajay, that those are belonging to the IT departments. So here the department is an input parameter to the stored procedures. Now the stored procedure with the output parameter. Okay, you can you can also return the values through output parameter. Okay, so let's create a new stored procedure. Okay, and stored procedure that will gives us the output. Okay, so here uh, we are going to create a procedure get total salary, and here we are passing department name as input parameter and total salary as output parameter. Okay, so here stored procedure is created. Okay, so how we can call the stored procedure with output parameter? So here first we need to declare a variable. Okay, and then here is the execute department ID total salary, and the total salary, for the total salary we are assigning the result. Okay, and now we are printing the result, so it gives us the result. So here the output keyword lets you return calculated values from the stored procedures. So what are the advantages of the stored procedures? So stored procedures are reusable and modular. It improves the performance, meaning it compiled once and execute many times as we call. It enhances the security. You can grant access to the procedures instead of the tables. It is easier to maintenance. Logic is centralized. It supports the error handling. Now, what are the types of stored procedure in the SQL Server? So in SQL Server, stored procedure can be grouped into four main types based on who creates them and how they are used. So first type is system stored procedure. Second is user defined stored procedure. Third is temporary stored procedure. And the fourth one is extended stored procedure. It is an older and less commonly used today. So let's go one by one in details. So first, we can discuss about the system stored procedures. So the system stored procedures are predefined by Microsoft, and it come built into the SQL Server. They are stored in the master database and starts with the prefix sp underscore, which sp stands for the stored procedure. So what is the purpose of system defined stored procedures? The system defined stored procedure perform the administrative or system level tasks such as creating logins, managing database, or retrieving metadata. So here is an example of the system stored procedures, that is execute sp underscore held db. So it displays the information about all the databases. So sp underscore who, it shows all the users currently connected. So sp underscore help text, okay, it displays the source code of a stored procedure. sp underscore columns, it lists all the columns of the emp table. Okay, so let's check this in real time. Okay, now so it gives all the databases we have. You can check here. Okay, abc database, eap database, school database, SQL server database, msdb model and master are the, and the temp are the system databases. Okay, so you can find them here. Now we can check all users currently connected using this command. So here is the login name, means here the user. Okay, username which are connected, host name. Now let's we can see the definition of stored procedure by using the sp underscore help text. Okay, let's check. Let's view it in real time. Okay, so we can have this get all employees. Okay, so it gives the definition of the stored procedure get all employees. Now let's check the columns of the table emp. Okay, here are the column names of the table employee. Here we need to consider some points. So don't create your own stored procedures with the name starting with sp underscore. So SQL Server always looks for them in a master database first, which can slow down the performance. Now, the second one is user-defined stored procedure. So these are the stored procedure created by you, the database developer, to perform the application specific tasks. So they can be without parameters, simple routines. With parameters means for the dynamic behavior, they can be with the output parameter, or they can be a nested or recursive. So let's create a stored procedure with this behavior in a real time. Okay, so the first one is we are creating a stored procedure without parameter. Okay, so already we have created a stored procedure. Okay, get all employees without parameter. So here you can see it's already been created here. Okay, so let's execute this. It gives us all the employees. Okay, now let's create a stored procedure with uh, the input parameter. Okay, get by department name. Here we can pass department name as input parameter, and we can pass the, means we can define the data type. Okay, here we can remove this column. Okay, and we can use the filter on the department name. Okay, so we have created the stored procedure with its parameter. And here is another way is to execute stored procedure. You don't need to specify the exec or execute keyword before the stored procedure. We can directly give the stored procedure name and the input parameter. Okay, so it gives us the result. Now create stored procedure with output parameter. So this is we have already seen. Okay, now recursive store procedure. So we can create a recursive store procedure here. Okay, let's put store procedure counter plus one. What? Okay, let's me declare another variable here. Just pass here counter. Okay, we have created a store procedure. Okay, now let's execute this and we can pass the values. Okay, so the counter value is 5. It gives us the counter value is 5. Now, so here we need to consider some points. That is, the user defined stored procedures are the heart of an application logic in the SQL Server. In the real projects, 80% of your procedure will be a user defined. They handle the insert, update, uh, reports and the validations. Okay, the third type of stored procedure is the temporary stored procedures. So the temporary stored procedures are stored in the temp database and are automatically deleted when the session ends for local and when the server restarts for the global. So types of the temporary stored procedures: the local temporary stored procedure and the global uh, temporary stored procedures. So here prefix is the procedure underscore name, hash procedure underscore name, and for the global temporary procedure we have a double hash procedure name. So it visible the local temporary procedure visibles only to your sessions, and the global temporary procedures are visible to all users until the server restarts. So here is the we can create a stored procedure, temporary stored procedure. Okay, local temporary stored procedure. Okay, we have created and now execute stored procedure. Okay, it gives us time. Now create a global temporary stored procedure. Here we have created the global temporary procedure and now we are executing the global temporary procedures. Okay, so here some point we need to keep in mind, that is you rarely use this in business app. Means we rarely use a temporary stored procedure in our business applications, but they are very handy for testing. For testing ETL processes or the temporary script where you don't want to leave a permanent object. And the fourth type of stored procedure is the extended stored procedure, and it is the legacy features. So these are the external routines written in C or C++ and registered with the SQL Server to extend this functionality. They starts with the prefix x XP underscore. That is for the XP stands for the external procedure. They run outside the normal SQL server process space, but can be called like normal store procedures. Okay, so here is the example. Let's check in the real time. Means it is not allowing us. Okay, we don't have access. So here are some points that we need to keep in mind. The extended stored procedures are the deprecated. They pose security risks since they can execute operating system commands. And if you need similar functionality, use shell stored procedure or extended service instead. So here, I mean, we can working with the stored procedure in SQL servers. Once you have created the stored procedures, you will often need to view, edit, delete, and execute them with the different parameters. Let's go through each operation clearly. The first one is to view the stored procedure in the current database. So you can see all the stored procedure in the current database using the several method. The first one is system view. Okay. So here using this syntax, you can see all the stored procedures in the current databases. Okay. Now here we have created 5 stored procedures. Okay, in the ABDB database. Here P means the stored procedure. This lists all the procedures created by user in the current database. The second option is using the system stored procedure. So we can check using the syntax. Okay, here is the stored procedures. Okay, it gives all these procedures. It shows all the stored procedure in the current database using the SQL Server man. The third option is using the SQL Server Management Studio. So for this, we can see all the stored procedures using the SQL Server Management Studio. So okay, so here is the database. In the database, you can go programmability. In the programmability, you can expand the programmability. You see the stored procedures. Okay, you can expand the stored procedure, and you can find all the stored procedures here. Okay. Uh, to view the code definition of stored procedures, you can use the exec exec. Okay, sp underscore help text and then the procedure name. Okay, so let's check this in real time. Execute sp underscore help text. Okay. Sorry. So it gives the definition of the stored procedure. Here is another option is, let's check this example. Okay, here it gives the definition. Okay, now to modify an existing stored procedure, you can use the alter procedure statement. Okay, so here is the syntax: alter procedure name, then as begin the new code or the updated code, and then it's. Let's see this in real time. Okay, here we have added the department name. Okay, so here you can see name, number, name, and salary, but you don't see the department name. So now we are altering the stored procedure. Okay, So it have successfully altered, and now run the store procedure. Okay, it gives all the employees with the department name. So here alter allow us to change a procedure without dropping or recreating it. This is the recommended way to make an update to the stored procedures. So if you want to delete the stored procedure, you can use the drop keywords. Okay, drop procedure command. Okay, here is an example. Let's drop this. Now the stored procedure get all employee stored procedure is deleted. So one point here we need to keep in mind is that always means before always check before dropping the store procedures. Okay, so it's checks means you can check using this syntax. Okay, now next is the stored procedure parameters. So the stored procedure parameter makes your stored procedure reusable and more dynamic. Let's go through the three common types of stored procedure parameter. The first one is the input parameter, second one is the output parameter, third one is the optional parameter or the default parameter. Let's discuss this parameter in details. So first is the input parameter. Okay, so input parameter is used to pass the value or to the stored procedures. So here is the syntax that create procedure name, then the parameter name, then the data type as begin, the statements means and the instance. Let's check this in real time. Now we are creating a stored procedures. Okay, by passing the department name as input parameter. Okay, so okay, sorry. So we have already created this stored procedure. Okay, let me drop this stored procedure first. Okay, now recreate the stored procedure. Okay, the stored procedure is created successfully. Now check the result of this. Okay, so it gives me three employees that belongs to the IT department. Okay, so you can pass different department names to get the different values. So let's check that. So let's first check uh, the values from the EMP table. Okay, we have IT department and the null department. So here we have get the values means get the employees that belongs to the IT department, and now we can pass the null. Okay, let's check. We can pass the empty. Okay, because null is not an value. Okay, now the second type of parameter is output parameter. So output parameter used to return a value from the stored procedure back to the correct program or the stored procedures. Here is the syntax: create procedure name, then the parameter name, data type, and the type means output. As begin, we can assign value to the output parameters. Okay, let's create a stored procedure in real time. Let me first drop the stored procedure. Okay, let's create the stored procedures. Okay, now we have created the stored procedures. So here we can get the result of the stored procedure by first we need to declare a variable. Then we can pass the department name as the input parameter, and then the total salary as the output parameter. Okay. Oh, my bad. Let's create. Let's drop this stored procedure. Varchar 50. We can change the data type to the varchar 50. Okay. Now let's create once again. And now let's check the result of this. Okay, it gives us the result. So the value assigned to the total salary inside the procedure is written into the variable result. Okay, the third one is the third one parameter is the optional parameter or the default values. So we can assign default value to the parameters so that passing them is an optional. Okay, so here is the syntax: create procedure name, parameter name, data type, and then we can assign the default values, then the use parameter. Okay, let's create the stored procedure with the default parameters. Okay, here is the optional parameter we are passing. Okay, we have created the stored procedures. Now let's check the result. First, uh, we are not passing any input parameters. Okay, so it gives us all the employees. Now we are passing the department name as the parameter, and it gives us the employee that belongs to the IT department only. So you don't need to pass the department name in the procedure shows all the records. The last one is combining the input, output, and the optional parameters. So here is the full example showing all these three types together. Okay, so let me create the stored procedure here. Okay, I have created a stored procedure get salary summary. The department name is optional, or okay, or we can assign the default values. Then the EMP count is output parameter, and the total salary is output parameters. Let's run execute the stored procedure. Okay, so first, uh, okay, we have declared the count and the total. Okay, and let's execute the get salary summary stored procedure. Okay, okay, here it gives the total employees 3 and the total salary is 18,950 rupees. So, exception handling in the SQL Server. So, an exception is simply an error that occurs while your code is running. Means it interrupts the normal flow of a SQL Server statements. So following are the situation that typically causes exceptions in the SQL Server. So it gives a dividing a number by zero. Another is trying to insert a data that violates the constraints, converting invalid data types, violating foreign key constraints, referring an object that does not exist means object is not set to an instance of an object exceptions. When any of these happens, then SQL Server throws an exception. If you don't handle it, SQL Server stops that batch and returns an error. To handle exception in SQL Server, we use try-catch statements. So here is the syntax of handling exception in SQL Server, that is try-catch structure. So here is begin try, then here is the statement SQL query, then end try, then begin catch, then the code that handles the exception or the error, and then end of the catch. Okay, so here a few things that we need to keep in mind, that is statements inside the try block are executed first. If an error occurs, control jumps immediately to the catch blocks. Okay, the catch block can log the error, display message, or a rollback transaction. Okay, that we need to handle. How we can handle the exception. Okay, so let's take the real-time example of uh, the divide by zero error. Okay, let me get this code and let me open the SQL Server Management Studio and paste it here. Okay, so here I have declared a variable int, okay, and assign the value to 10. Then again I have declared another variable b, and I have assigned value it to 0. Then I have declared variable c, so c will store the result of a and b. Okay, so here we are setting the value of c, that is variable a divided by variable b. So okay, so this will cause the divide by zero error, because whenever we divide any value with the zero, then it will throw the divide by zero error. Okay, and we are printing the result here. Okay, and in the catch statements we are just logging the error message. Let me execute this. Okay, so it gives us an error occurred divided by zero, error encountered, means this statement printed, and this statement is not printed because we got the exception at this line. Okay, now so it gives us the output like an error occurred divided by zero, error encountered. Here is the SQL server stop the executing the try blocks as soon as it hits the error, means here. Okay, here we get the exception, then it will not execute this line, so it directly come into the catch block and print the error message. Okay, the catch block runs immediately after that. So following are the functions that available inside the catch blocks. Inside the catch block, the SQL Server gives you 6 special functions to get the detailed information about the error. The first one is error underscore number, means it returns the error number. The second function is error underscore severity. It returns the severity level, means how serious the error is, means how critical the error is. The third one is error underscore state, so it returns the state number of the error. The fourth one is error underscore procedure. It returns the name of the procedure where the error occurred. The fifth one is error underscore line. It returns the line number where an error occurred. And the last one is the error message. It returns the full text of the error message. Okay, so let's take an example of using these functions, 6 functions, okay, in the real time. Let me take this and let me open the SQL Server Management Studio and paste it here, okay. So I have printed, means I have used 6 functions that we just discussed, okay. Let me execute this one. So it gives the error number 8134, severity is 16, state is 1, procedure is not in procedure, okay. Line number 3, here is line number 3, 1 2 3, and the message is divided by 0, error encountered, okay. So this is the output of that. Now the types of errors in SQL Server. In SQL servers, errors can be divided into 3 broad types, and those are the system errors, user-defined errors, and the batch aborting errors. The description is the system errors means SQL generates that error automatically. Example is divided by 0 or constraint violation. Okay. The user-defined errors means that error manually raised by the developer using the raise error or the throw keywords. Means if we want the custom business logic errors, that time we use the user-defined errors. And the batch aborting errors is it stops the current batch, but it keeps the connection alive. Means the conversion error or arithmetic workflow errors. Okay. So let's think of a transaction as a promise. Your database makes either the whole group of steps happens or none of them do. In another way, a transaction is like a sending a sealed package. You either send the whole package commit or you open it and put everything back how it was, like rollback. A transaction is nothing but a set of SQL commands that will execute as a unit or a single block. A transaction contains TML commands and is mainly used to provide security for the data in the table. Transaction makes sure that your database stays consistent even when there are errors or failure happens. Transactions are used heavily in the banking, accounting, inventory, and the payroll systems. So here is the basic syntax of transactions. This is the explicit transaction. So begin transaction. Here so here is the begin transaction. Then we are updating, we use the update statements inside the transaction. If everything goes good, then we can commit the transaction, and if something goes wrong, then we can roll back the transaction. Let's see this in real time. Okay. So here before doing that, let's see the value of account table. Okay. So here for the account ID 1, account name is John Carter, email is john.carter@example.com, and the balance is 1300, created it, and this empty. Okay. So let's execute this state this transaction. So inside this transaction, we are going to update the account. Okay. For the account ID 1 and account ID 2. Let's execute this. Okay. Now let's check values. So it gets updated balance. Okay. Means everything uh, works good. Okay. Now consider that there is some exception occurs. Okay. Let me comment out this section. Now let me execute this. Okay. Now let's see the value 1200 and 550.75. Okay. Before that, let me execute this. Now 2 rows are affected. Let's check the value. It's updated. Okay. Now let me roll back this transaction. Consider that there were some exception or errors. The transaction was rolled back, and let's see the values. So it's reverted back to the original value. Okay. So here some points we need to note. So the begin transaction, it creates a local transaction. Commit transaction makes changes permanently into the table. Rollback transactions undoes changes since the begin. Okay. Now uh, the types of transactions. There are two types of transaction. One is the implicit transaction and the explicit transactions. So let's go in details for the implicit transaction and the explicit transactions. So implicit transactions, it auto commits. Okay. So SQL Server auto commits its statements. This is the default transaction type. Single statement auto commit. It is the default transaction in SQL Server. When the SQL command execution is completed, then commit will work automatically and changes will save permanently in the table. Implicit transaction will be created by the SQL Server. Okay. Let's check this in a real time with this example. Okay. So let me uh, get the data from the EMP table first. Okay. So you can see the last employee is Ajay. Okay. Let me execute this. Okay. Now one row is affected. Let me get the data for this. So the last one is inserted. Okay. So means it committed automatically. Now the second type is explicit transaction. This transaction will be created by the user or the SQL Server developer. To start the transaction, begin transaction is used. To close or end the transaction, rollback or commit is used. This is most common and recommended method of the transactions. You start, commit or rollback manually. Okay. So let's here is the syntax for the explicit transaction. Begin transaction, then some SQL statements, then if everything goes right, okay, then we can commit the transaction, or if there were some error occurs, then we can roll back the transaction that we have seen earlier. Okay. So one point here is to remember is that rollback is used to cancel the execution of SQL commands, and commit means the changes will be saved permanently in the table. So some points to be we need to remember in the production system. Every data modification like insert, update, delete should be wrapped inside the transactions. Always log error and rollbacks. Its silent failures are worse than exceptions. Use transaction with isolation levels for concurrency control. Keep your transaction as small as and fast as possible. Long transaction block the users. Okay. So the save points or the partial rollback in the transaction. So save points are lifesavers in complex flows. You can undo part of a transaction without abounding the whole things. Here is the example. Okay. So begin transaction, update order, set status equal to processing where ID equals to 1. Here is the save transaction, save transaction point, save 1, that is the save point. Then use the update order, set status equals to failed where ID is 1. So here we are roll back to the save point, undo only after save 1. Okay. So for that we use the rollback transaction save 1 and commit transaction. Let's see this in real time. Okay. So before this, we can check the what is the data inside the order table. Okay, just wait. Okay, okay, let's make use of DBO. Okay, okay. Now let's execute this. So here you will see the details of the order table. Okay, now execute this. Okay, sorry, here is column name is order ID. Let me update this ID with order ID. Okay, now let's execute this. So two rows are affected. Okay, let's execute this and get the data. Okay, you will see the data. Okay, so this is about the save points in transactions. Now how errors are handled in the transactions. So when you are working with a transaction, always combine them with the error handlings. Always handle error and ensure rollback on the failure. For this, you can use try catch that ensures that your data stays consistent. If an error happens, you roll back, otherwise you can commit. Okay, let's uh, see in the real time. Okay, so here we can use the try catch. Okay, inside for the transactions. Let me execute this. Okay, the first one row is inserted. Okay, when then we are updating the employee with the salary divided by 0, then these statements cause the error. Okay, so it gives us the so here we get the error, then it came here. Okay, in the catch block. So here it's roll count, transaction count is greater than 0. Okay, and so it rollbacks the transactions, and now we are declaring a variable error message. So here for the logging the error message, and then we are using the trace error to print the details. Okay, so message 50,000 level 16 state 1 line number 11. Okay, so you can see the line number 11, and here is transaction failed, and it gives the message that is divided by 0, error encountered. Now here is some explanation of that. If any error occurs inside the transaction, then the catch block rolls it back automatically. Okay, this is critical for maintaining data integrity in production databases. And some notes are here. Always wrap critical operations like insert, update, deletes inside the try catch block. You can prefer throw over raise error in SQL Server 2012 and later. It's cleaner. Always include rollback in your catch block if you use transactions. Log detailed error info using the error number and the error message for auditing purpose. Keep transactions short. Okay, and do not do the UI work inside the transactions. So some like waiting for user input, it will block until the transaction exit will executes. Okay. Avoid unnecessary locks. Index properties. Prefer optimistic concurrency. Row versioning when many readers and few writers. Log meaningful context in the error handling like transaction ID, user ID, operations. Test under load to see log contention and deadlocks. Reproduce and fix. You can monitor using the sys.dm translog dm underscore execute underscore request. Then sys.dm underscore os underscore waiting underscore tags for live debugging. The triggers in SQL Server. So what is the trigger? Trigger is a program that will perform a specific task when it is executed. Triggers are used to give a condition or rules on a tables or else on a database or else on an entire SQL server like on all databases. To overcome the drawback of constraints, triggers are introduced. Constraints will work on tables and will work on insert and update commands. Trigger will work on insert, update, delete, create, alter, and drop commands. A trigger will be executed implicitly, means SQL Server will execute a trigger internally. SQL Server contains after triggers instead of triggers, DDL triggers and the CLR triggers. After triggers and instead of triggers will work on DML commands. DDL triggers will work on the DDL commands. After trigger means after insert or after update or after delete commands. You don't call a trigger manually. It fires or it executes automatically when a specific events like insert, update, delete or DDL operations happens. Triggers will execute after or instead of an event depending on type. So a magic table means it contains the column of a table on which the magic table is created. The magic table will exist only at the time of the execution of the trigger program. A trigger execution will take a few milliseconds. Okay. So there are two types of the magic tables. The first one is the inserted magic table and the deleted magic table. So in the inserted magic table, new record given in the table will be stored in the inserted magic table. In the deleted magic table, the records deleted from the table will be stored in the deleted magic table. If you open a table to insert, update or delete rows, SQL Server can fire a trigger before or after that action completes. They are often used to keep data consistent, enforce rules, or track changes without relying on application code. So here is the trigger syntax. There are two types of trigger syntax. The first one is the older version and the second one is the new SQL Server syntax. In the older version of syntax, we use the create trigger name for after trigger or instead of trigger or DDL triggers on the table name or on database or on all servers as begin their statements and they need. In the new SQL Server syntax, we use the create trigger name on table name, database or server for after trigger instead of trigger DDL triggers as begin statements and they need. Okay. To modify triggers, we use the below syntax, that is the alter trigger, then trigger name. So to view the triggers in the current database, we use the select star from sys objects where x type equals to tr. Okay. So let's check in real time. Okay. Let me open the SQL Server Management Studio. Let me connect. Let me open a new query tab. and go to the database. Okay, now let me execute this command. Okay, so let just give a second. So right now we don't have any triggers. Okay, so to view the definition of triggers, we can use sp underscore help text, the trigger name. To delete trigger, we can use the drop trigger name. So if it is on the database, then we can use on the database, and if the trigger is for all servers, then we can use on all servers. Okay, so now let's have a look on the types of the triggers. So the SQL Server contains four types of triggers, and those are the DML triggers, TDL triggers, logon triggers, and the CLR triggers. So let's discuss one by one. So first is the DML triggers. So DML triggers are the most common triggers. So these are the ones you use most often. And the DML trigger fire automatically when a data change happens. Okay, like insert, update, delete on a table or a view. So again, there are two types of the DML triggers. First one is the after trigger. This is the default one, and the second one is the instead of triggers. So let's discuss one by one. So first, discuss the after trigger, the default one. So after trigger executes after the DML operation completes successfully. After triggers fires after the triggering actions. Okay, the insert, update, and delete statements causes and after trigger to fire after the respective statements complete execution. So for this we have created two tables. Okay, the first one is the employee and employees audits. So let's check employees, and the second one is employee audit. Okay, now let's check the data inside this. Okay, now now we can see the example in a real time. Okay, so first example is we can create a trigger for the insert. Okay, on employee tables. Okay, let's check this in real time. So here is the example of creating the insert table, insert trigger on the employee table. Okay, so when the insert statements happen on the employee, then it will insert the data into the employee audit. Okay, let's create a trigger. So I have created this trigger right now. Okay, so to check whether this trigger is working fine or not, we can execute the statements, like we can give the employee ID as 10 for the employee name Sanjay. Okay, and this is the salary. Okay, let me execute this one. So here you can see there are one row affected means total two rows affected. So first row is for insert the data into the employee table, and the second one is for inserting data into the audit tables. Let's check in the real time. Okay, let's execute. So here you see the Sanjay is added, and if you scroll down, you can see new employee with ID 10 is added. Okay, at November 23rd, 2025. Okay, now let's check uh, another example for the delete. Okay, let's create another trigger for the delete statement. Okay, so here we are creating a trigger, okay, on employee table for delete. Okay, and in the after delete, okay, we are just logging into employee audit. Okay, so here is the employee with ID is deleted at. Okay, here is the message we are logging here. Let me execute this. Okay, now I have created the trigger. Let me check whether it is working fine or not. Okay, uh, let me delete the recent one, employee. Okay, so now one row is affected. Let's go here and check this one. Okay, this is the another one. Now you can see the message, employee with ID 10 is deleted at, this is the date and time. Okay, now let's create another trigger which will not allow user to add, update or edit or delete the records from the table. Okay, so let me create a new table, new trigger which will not allow or any user to insert or update or delete data from the employee table. Okay, now I have created this one. So to check whether it's working fine or not, uh, let me execute the first insert statement. So here you see the DML operations are not allowed with the same message. Okay, so for update you will see the same message, and for the delete you see the same message. So now the second type is instead of trigger. So we discuss this in detail. Exit means instead of trigger executes in a place of the DML operations. Instead of triggers fired, instead of the triggering actions, the insert, update, delete statements causes an instead of trigger to fire instead of the respective statement execution. With instead of insert, the value when insert command is executed, then the value will go only into the inserted magic table, but the value will not go to the table on which trigger is created. So instead of trigger can be used on table or view. Instead of insert, trigger is basically used to update a view having multiple base tables. And instead of trigger is a special kind of trigger in SQL Server that replaces the normal action of an insert, update or delete statement. So normally when you run the statement like the delete from the employees where id equal to 1, so then SQL Server deletes or removes those records or rows. Okay, but if there is an instead of delete triggers on the employee table, the SQL Server won't delete the row directly. Instead of it runs the trigger instead of the delete operation. That means the trigger takes control. It decides what to do next. It might log the change in another table, apply custom business logic, or even prevent the change altogether. So let's check this in real time with the example. Okay, let me create the instead of delete uh, trigger. Okay, okay, now I have created the trigger. Okay, let's delete one employee, delete employees. id equals to 7. So here it gives us message like the deletion is not allowed directly on employee tables. Okay, now let's check the employee audit log, employees audit table. Okay, so here you can see the message, the employee with id is attempted to delete at means the date and time. So here is some note. Now if someone tries to delete on the employee records, SQL Server runs this trigger instead of deleting the row. So the deletion is locked, but the row stays in the table. It is not actually deleted. When to use an instead of trigger. Okay. So you want find control over what happens during data changes. So that time you can use the instead of trigger. Also, you need to enforce the business rules that SQL constraints alone can't handle. Okay, and also you are working with the views because you cannot normally perform insert, update, or delete directly on complex view, but you make them updatable using the instead of triggers. So in these three situations, you can use the instead of triggers. So here is an example of the view. Okay, so let's say you have a view that joins the two tables. Normally, if you try to insert into the view, SQL throws an error. But if you use the instead of trigger, you can make the view. It means it works. Okay, so let's see this in a real time with the example. Now, so I'm going to create a view, that is view employees audit. We are selecting the ID, name, and the audit data, okay, from the employee and the employee audit table. Now I have created the view. Let me create a trigger, okay, instead of trigger on the views. Okay, now I have created the trigger on the views. Okay, let's check whether it's working fine or not. So now I'm going to insert the values into the view. Okay, okay, so DML operations are not allowed. This is the trigger, that means this gives the validation because of we have created the trigger. Okay, ID, name, salary. I put it. Okay, okay, let me drop this trigger, that message, because of the we have created the trigger on the delete. Okay, now drop this trigger. Okay, let's execute this one. Now here is we got the three rows affected. Okay, let's check the values from the employee and the employee table. Now here you can see Ajay is get added. Okay, okay, with ID 2. Now you can see the message here is the new employee with added at member, and this is the time. Okay, So normally when you try to insert into the view, then the SQL server will throw an error. But with an instead of trigger, you can make view work. Now you can insert the data into the view, and the trigger will take care of inserting data into the correct base table. Okay. So here are some points to be need some points to be remember. So instead of trigger, replace the default actions. They can be used on a table or views. You can only have one instead of trigger per actions. Okay, and they are great for customizing or restriction data changes. Now the second type is the DDL triggers. Okay, so this trigger will work on the create, alter, and the drop commands. So it is used to create a database level trigger and the server level triggers. DDL triggers are special triggers that fire in response to schema change, not the data change. That means instead of reacting to the insert, update, or delete like DML triggers, they respond to commands such as the create, alter, drop, grant, deny, revoke, rename, and other database or the SQL level DDL operations. So while DML triggers watch data, DDL triggers watch structures. When to use the DDL triggers? If you want to execute some code in response to a specific DDL event, okay, to prevent certain changes on your database schema, audit the changes that the user is making in the database structure. So in this scenario, you can use make use of the DDL triggers. So here is the syntax. Okay, so create trigger name on the, here is the scope like the server or on the database. Here is the for event and the as begin the statements. Now so let me create one, means we can see the one example of DDL triggers. Okay, so here we are creating a trigger, okay, that will not allow to create table or alter table or the drop table, okay, on this EMP database. So now I have created the trigger. So now I'm trying to create a table here. Okay, so here is already employee is exist, employee table is exist. Let me give change the name of the table. So now it gives me the message like the DDL operations are not allowed. Okay, so the third type of trigger is the logon trigger. So as the name implies, a logon trigger fires in response to the logon events. Logon triggers fires after the authentication phase of the login is in finishes, but before the user session is actually established. So logon triggers can be used for tracking login activities, restricting logins to SQL Server, or limiting the number of sessions for a specific login. So to check the active user sessions, okay, you can use this command. Let's check this. Here is the command. So you see, these are the active sessions. Okay. So here is and the syntax of the logon triggers. Create trigger name on all servers for logon as begin. Here is the logic, whatever you want, and then the end. So here is the example of the logon triggers. Let's check this in real time. So now I'm creating a trigger with the TR audit login. Okay, let me execute this one. Okay, I have executed this one and created the trigger. So here this we can use this query to check the errors. Okay, and the last one is the CLR triggers. So CLR triggers are triggers based on the CLR. CLR integration is new in SQL Server 2008 and it allows for the database objects such as the triggers to be added in .NET. We can code both TDL and DML triggers by using supported CLR like C#. SQL Server. Cursor is a database object used to retrieve, navigate, and process rows from result set one record at a time instead of all at once. It's process row by row processing. Normally, SQL works with complete result sets. A cursor is useful when you must apply logic to each row individually. Cursor can be called as a workspace or a private sector area or a buffer. Cursor is the memory location where SQL tables are stored. So the types of cursors, there are two types of cursors, implicit cursor and explicit cursor. Let's discuss one by one. So first we will discuss about the implicit cursor. So this type of cursor will be created by SQL Server. The table stored in an implicit cursor will be accessed by select statement. This is automatically created by SQL Server for statements like select, insert, update, delete. The user does not create or control this type of cursor. Processes data internally without row by row navigation by the programmer. Now discuss about the second type of cursor, which is nothing but the explicit cursor. This will be created by the user. The table stored in an explicit cursor can display the records one by one or record by record. It can show records in forward and backward directions, that is from first to last or last to first. This is created and controlled by the user. It allows moving through records one row at a time. So when to use explicit cursor? So when we have a row level business logic is needed and the dependent calculation must run per record. So what is the cursor life cycle? An explicit cursor always follows these steps, that is first declare, then open, then fetch, then close and the deallocate. So declare means we can define a cursor, open means execute a query and create result set, fetch means retrieve one row at a time, close means release current result set, and deallocate means remove cursor from memory. So here is the syntax of explicit cursor, that is declare cursor name cursor for select statements, then open cursor, then fetch first, private, next, last from cursor name into the variables, then close cursor name, deallocate cursor. So we can see a real-time example to create a cursor to display records from employee table. So let's see this in real time. Okay, Let me open SQL Server Manager Studio and let me create a cursor. Okay, so here I am declaring three variables like e-number, e-name and the t-salary. Okay, then I am going to create a cursor, that is C1. Declare cursor, cursor1. Declare C1 cursor for select e-number, e-name, salary from EMP. Then open cursor, that is C1. Fetch next from C1 into T e-number, T e-name and the T salary. While at the first underscore status equals to 0, then begin. Now here I am printing the T number, T name and T salary. Okay, fetch next from C1 into the T e number, T e name, T salary, then close end, then close C1 and deallocate C1. Okay, okay, let me execute this. So it gives me 13 records. Okay, that is Sanjay means employee number, employee name and the salary. Okay, now here is some points we need to keep in mind, that is at the rate page underscore status is the predefined global variable used to check whether the cursor fetch operation was successful or not. So the condition meaning. Okay, so at the rate fetch underscore status equals to 0, then it gives us successful, that is record is found. At the rate fetch underscore status equals to -1, then no more records, that is end open cursor. Then at the rate fetch underscore status equals to -2, then it gives fetch error or row is missing. If the cursor is not containing any records, then at the rate fetch underscore status variable value will be a -1. So cursor types. So there are 4 cursor types, that is static cursor, dynamic cursor, key set cursor and fast forward cursor. So let's discuss one by one. First we will discuss about the static cursor. So static cursor will be creating the cursor and the results it is stored in a table variable. Data changes made in the underlying table will not be reflected after opening the cursor. Result is copied into a temporary table. Changes made to a base tables are not visible in cursor. It is slow but stable. So the second one is our dynamic cursor. So this is the default type of cursor. Data changes made in the table will reflected in the cursor while it is fetching. So it reflects real-time changes. In insert, update, delete shows during fetch. Uh, it uses more memory and processing cost. So third one is the keyset cursor. So while creating explicit cursor, if cursor type is given as keyset, then for each record in the explicit cursor is a key. A key is used to uniquely identify each records in the explicit cursor. All the keys will be stored in a table and then the values will be stored in the DB. Only the primary key values are stored. data changes are reflected except new ones added, allows updates and delete on existing rows. The next one and the last one is fast forward cursor. So if explicit cursor is fast forward, then the explicit cursor will be a forward only and read only. Forward only means records can be accessed only in a forward direction, and reading the value in explicit cursor cannot be modified or deleted. Forward only means plus read only. Okay, it gives best performance. It cannot scroll backward or modify data. So the navigation types in cursor. So there are two types, that is forward only, this is the default, and the scroll. So let's discuss one by one. So first discuss about the forward only. So this is the default. It will show the records in forward direction only. Cursor moves only forward. Supported fetch options are the next. It supports only one option, that is next. The second one is the scroll. Okay. So it will show records in forward and backward direction, allows bidirectional movement, and it supports the fetch options like first, last, next, and the prior. Then the lock types. There are two types of locks. The first one is the read only and the optimistic. Let's discuss one by one. Let's discuss about the first one is the read only. While creating an explicit cursor, if lookup is read only, then the values in the explicit cursor cannot be modified or deleted. Retrieved rows cannot be modified or deleted. It is the fastest options. The second one is the optimistic. While creating a cursor, if lock type is not given, then the default lock type will be optimistic. This lock type allows users to do changes in explicit cursor. It allows row modifications. The rows are locked only during update, not during fetch. It has the best concurrency. So here is the syntax of cursor declaration with the options. That is the declare cursor name, cursor, with the option like static dynamic key set forward. Okay, then forward underscore only or scroll. These are the navigation type. Read only or the optimistic. These are the lock types. For the select statements, that is the default one. Okay, so now we can discuss about the local cursors. So if explicit cursor is written inside a trigger or stored procedure, then it is called as local cursor. It can be used in .NET projects. A cursor declared inside a trigger or stored procedures exists only for a duration of that block, commonly used in .NET linked SQL operations. So now we can see another real-time example of an explicit cursor to display records from employee table in the backward direction. Okay, let's see this in the real time. So here I am going to create a cursor, means cursor. Okay, before that I am going to declare three variables, that is the TE number, TE name, and the T salary. Now I am declaring a cursor with the option that is scroll for, then the select statement, select employee number, name, salary from the MP. Then I am going to open a cursor, then fetch last from the cursor, that is 7 into the variable, that is t e name, t e number, and the t salary, while at the fetch underscore status equals to 0, then we are printing this value, and then the fetch prior from c1 into this variable. Okay, so here prior means it retrieve the previous rows. Okay, now close cursor and then deallocate cursor. Let's execute this and see the record. Okay, so here is the employee ID, means it printing last to first. Okay, the 13, 12, 11, 6, 5, 4, 3, 2, 1. Let's see this from here. Okay, from the employee table. Okay, here is the Ravi, Ajay, Rao. This is the in this is the ascending order, but we are using the last option, so it will gives us in last first. Okay, here. Now let's discuss the advantages of the cursor. It handles row level logic easily. It is useful for the complex validations. Uh, it is necessary when rows depends on the previous row result. So what are the disadvantages of cursor? It is slower than set-based queries. It uses high memory and CPU, can block other operations, and it has the poor scalability. So here are some points we need to consider: when to use cursor and when to avoid. So avoid cursor when possible. So before cursor, you can use the alternative like prefer set-based queries, use join, city, merge statement, or the while loops on the temporary tables for the better performance instead of cursor. SQL Server. So a function is a program will perform a specific task when it is executed. A function in SQL Server is a database object that accepts input parameter, perform logic or calculations, and returns a value or a table. Function will reduce the repetition of writing the same code for several times. Function will have return type and will return a value. In function, DML statement will not be used. Function will contain select statement and other procedural statements. It can be used in set queries like select, where, join, etc. So 5 functions are used. So in real projects, functions are used to avoid repeating complex logic in many queries. It standardizes business rules, that is the calculations, tax logics, formattings. It improves readability of queries. It encapsulates calculation that belongs close to the data. Here is an example. Instead of repeating an age calculation everywhere, you write once and reuse it. So the types of functions, there are mainly 2 types of functions. First one is the predefined or the system or the built-in functions, and the another one is the user-defined functions. So let's go through uh, these one by one. So the first one is the predefined or system or built-in functions. So these are the functions provided by the SQL Server out of the box. Following are the predefined or the system or built-in functions. Here are the string functions. So the string functions are the length, substring, upper, lower, trim, trim, rtrims. So the next system or predefined function is the date functions. So date functions are the get date, date difference, date add, year, month, day. Okay, and then another system or predefined function is the math functions. So it includes absolute, abs, round, ceiling, and floor. And the another one is the conversion function, so it includes the cast and the convert. So here is the example of get the date difference. Okay, select date difference, then year, then here is the date and the get date. Okay, so these functions are heavily optimized and should always be preferred over custom logic when available. So let's see this date difference function in the real time. Okay, so here uh, is this the different functions, so it gives us 30. Okay, so if we put this as the 90, then it gives us the difference is 35 years. Okay, now the second type of function is the user defined function, which can be called as the UDF. So these are the functions that is created by you. Okay, so here is the syntax of the functions, user defined functions. The create function, function name, then the arguments, then returns, then the return data type as begin, the logic, and then return value and the end. Okay, so here is the example of this the user defined functions. Let's uh, see this in real time. Let me create this function. Okay, I have created these functions and let me execute this function. Okay, so I'm passing uh, the date as the input parameter and it gives me the year, okay, as 33. So here it returns integer and we are returning the age as integer. So to call the functions, to call or execute function, you can use the select dbo.function name, then the list of arguments. To view the function in the current database, we can use this syntax. Let's see this in practical. Here you can see the one function that is we created just now. Okay, okay. So next, to view the statements in the current function, we can use the sp_help text, then function name. Let's see this in a real time. So here is the function name. Let's check. So here is the statements that we have used inside the each functions. Okay, now so to delete the function, we can use the drop function and then the function name. Let's see this is in a real time. Let me delete this. Okay, now function is deleted. So when you execute these statements, the select statements, then you won't see any function is created yet. Okay, now so there are multiple types of the user defined functions, and those are the scalar functions, inline table value functions, and the multi-statement table value functions. So we can see this one by one. So the first one is the scalar functions. Okay, so the scalar functions may or may not have a parameter, but it always return a single or the scalar values. The return value can be of any type except the text, in-text, image, cursor, and the timestamp. Here is one point we need to keep in mind, that is when calling a scalar user-defined functions, you must supply a two-part name name, that is owner name dot function name. Here is an example of select let's create this function again. Okay, so here is an example of this one. It gives the owner name and the function name. Okay, or you can also give inokit by using compute three part name, that is the database name, owner name, the function name. Let's uh, check this in real time. So here is the database name, then the owner name and the function name. So it gives us the same. Okay, now the second user defined type function is the inline table type table valued function. So a scalar function returns a scalar value and the inline table valued function returns a table. So here some points we need to keep in mind, that are we specify table as the return type instead of an scalar data type. The function body is not enclosed between begin and end blocks. The structure of the table that gets returned is determined by the select statement within the function. So here is the real-time example. Okay, let's check this in a real time. So let me create a function, that is the function get employee by department name, then the input parameter is the department name, and it returns the value. It don't have the as means begin int statement. Okay, now function is created. Okay, let's execute this one. So here you see the result, that is employee name, employee number, employee name, salary, and the department is IT. Okay, so where we can use inline table valued functions. So inline table valued functions can be used to achieve the functionality of a parameterized view, or the table written by the table value function can also be used in a joins with other tables. So let's see the third type, that is the multi-statement table valued functions. So it can contain the multiple SQL statements. It uses the begin and end statement. Table structure is defined explicitly. It's slightly slower compared to inline functions, and use it when logic is complex. So here is the example of a multi-line multi-statement table valued functions. So let's check this in real time. Let's create another function. Okay, so here is the function multi amstvf get employee. Okay, and returns as a table type. Okay, now the function is created. Let's check this the value of what this function return. So it gives us the all the values. Okay, so to execute the multi-line multi-statement table valued functions, we use the select start from the function name. Okay, so the difference between inline table valued function and the multi-line table value functions are in an inline table valued function, the return clause cannot contain the structure of the table uh, the function returns, whereas in multi statement table valued function we specify the structure of the table that gets returned. In inline table valued function can't have begin and end block, whereas multi-statement table valued function can have it. Inline table valued functions are better for performance than the multi-statement table valued functions. It is possible to update the underlying table using and inline table value functions, but not possible using multi-statement table value functions. So the important concepts related to the functions. Okay, so deterministic and non-deterministic functions. The deterministic functions always return the same result anytime they are called with a specific set of input values and gives the same state of the database. Example, the square, power, sum, average, and the count. Note all the aggregate functions are deterministic functions. Non-deterministic functions may return different results each time they are called with a specific set of input values, even if the database state they access remains the same. So example, get date and the current time tab. So the third one is the rank functions is a non-deterministic functions, but if you provide the seed value, the function becomes the deterministic as the same value gets returned for the same seed values. So another one is the encrypting functions. Encrypting a function's definition using the with encryption options like use with encryptions. Creating a function with schema binding options. Schema binding specifies that the function is bound to the database object that is references. When schema binding is specified, the base object cannot be modified any way they would affect the function definition. We can use the with schema binding. So we can see the example of with schema binding. So let's check this example in real time. I have created these functions. Let me call this function. So what is the function name? And let me remove this DBO first. Let me give the function name and let me give the input as one. So it gives the name Vijay. Okay. Now we can see the real-time example with the schema binding functions. Okay. Let's check this in a real time. Okay. Now so it gives you the name as Sanjay. Okay. So what is the DBA commands in SQL servers? So the DBA commands are used for creating the databases, managing databases, importing data, exporting data, to take a backup, database backup, to restore database, creating users and managing users, database replications, log saving, database mirroring, etc. So we will focus on the backup and restore now. So to there is first method for backup. Okay, so backup is used to create a backup file of for the database, and restore is used to create the database using the backup files. So here is the syntax of the backup file. Okay, so backup database, then database name, to disk, and here path and file name. Okay, so here is the example of backup. So backup database empdb to disk d empdb backup. So let's check this in real time. Let me open this. Okay, now let me execute this. So it gives the data backup database successfully. Okay, let's go to the D drive. Okay, and you can see here the DB backup. Okay, empdb backup is created. Now this here is small note. This backup is a full backup and it will contain tables, records, views, indexes, synonyms, sequence, procedure, triggers, and the functions. So now to restore the database, here is the syntax, that is the restore database name from disk. Here is the path and the file name. Okay, so let's check this in real time. Okay, so let me uh, copy this restore command and let me paste here. Okay, now I'm restoring uh, the EMP database to the sample EMP database. Okay, let me first refresh here. You can see I don't see any sample EMP database. Okay, now let me execute this command. So the restore database successfully. Okay, now let me refresh this. So here I can see the sample EMP database is created. Okay, now the types of backup. There are three types of backup. First is the full backup, differential backup, and the transaction log backup. So let's discuss one by one in details. The first one is the full backup. So in full backup, all the pages within the database are captured that contains your actual data. Without performing a full backup, a differential and log backups cannot be possible. Full backup can be performed on any database having recovery modes like simple, full, and the bulk locked. The second one is the differential backup. So when backup is taken for the second time on the same database, differential backup can be used. So it will store only the recent data present in the database. So the differential backup captures all the pages that have changed in the last full backup. Okay. The primary purpose of creating a differential backup is to reduce the number of log backups. So you cannot take a differential backup of the master databases. So the third one is the transaction log backup. So every database contains primary data files and the log files. To store log data in the log files, transaction log is used. So here is the second method to create a database using the primary data files. So here is the steps we need to follow the steps. Okay, so find the location of the primary data file and the log file of the database. Okay, for example, here is the C program files, Microsoft SQL Server, then this type, and here I can see means any MDF file and the LDF file. Okay, so then the second step is detach files from the database. So for that you can use sp underscore detach underscore db, then the database name. Okay, now copy the files to the required locations, and then the fourth step is create database by using primary data files. That is the here is the syntax: create database, then the database name on file name, that is empdb.mdf, and this is for the attach. Okay, here here is a note that to use a backup file or primary data file in another system to create a database which is having SQL Server older version, then database properties should be changed. Okay, and the fifth step is click on view object explorer, click on database, right click on new database properties options, and then set the compatibility mode to the older version. Okay, now let's see the third method of creating the database using the SQL script. Okay, in SQL script, file records in the table will not be copied. Script will contains the table, views, indexes, synonyms, sequence, stored procedures, functions, trigger, etc. So here is the steps to create the script. Click on view object explorer, double click on database, right click on the EMP database, task generate script, click on the entire database and the all database objects. Next, then give the file name. then location, and then the close. So delete the EMP database, double click on the script one, then it will open in the management studio, select all the lines and press F5, EMP database will be created. So we can check this in the real time. Okay, let me go here. Let me go view, object explorer. Here you can come. Okay, let me go to this and click on task. Then let me click on the generate script. Okay, let me click on the next. So from here I can select all. Okay, tables, views, stored procedures, user depend functions, and the DLL triggers. Now click on the next. Okay, now here you can select the drop and create. Okay, or script drop and create. Okay, now here you can select type of data to script. Here I am selecting the schema and data. Okay, now click on the OK. Here I'll save this file on the desktop, give this as the sample db, click on the next, click on the next. Now it will generate the script. Okay, let's wait. Now the script is created. Let me click on the finish and let me go to the desktop. So here you see, okay, the sample db script is created. Let me double click on this and click on this. Here let me first delete this sample db. Okay, let's now create let me execute this script. Okay, let's wait while executing the script. Okay, let's wait. Likewise, using this script you can create a new database. Okay, now the next part is the security for the database. So the first one is the schema. So it is used to group tables and all the another objects. Like here is the DBA, then the user 1, user 2, user 3. Then we can create a schema on the table 1, table 2, table 3. Okay, so DBA will give privileges or rights to the users so that they can work with the tables and other objects. Instead of giving privileges to each and every table, tables can be grouped by using a schema. Okay, The privileges given to the schema will be applicable for the table in the schema. So first, create a schema. Here is the syntax for creating a schema. Okay, let me use the CMP database and then the my schema one. Give the name. Okay, the schema is created. Now, here is the example. Let me create a table using the my schema. Okay, the transaction with the trigger batch has been aborted. Okay, let me use another one database. Okay, let me create this schema and let me execute this. Okay, now table is created. Okay, so let's start from big trail. If you execute this, then it gives the invalid object name because we need to pass this schema name. Okay, now let's execute this one. So it gives us the empty table created. Okay, if the table is created without a schema name, the default schema is the dbu, that is the database owner. Then the second one is the login. So the login name is used for authentication or used to connect to the SQL server. Each login name will contain the database user and the user allowed to work with the tables and other database objects. Let's syntax for creating the login name. So here is the syntax: create login name with password, then default database, that is database name. Okay, let me create this one. Here is the real-time example. So here I have created a login name as Vijay with the password. Okay, so if you want to change the password, then you can use this command. Let's check this in real time. So alter login Vijay and change the password to the XYZ. Okay, now the password is changed to the XYZ. So create username. So here is the syntax for creating the username: create username for login, then the login name with default schema, that is schema name. So let's create this username in the real time. Okay, my user for login user and with the schema one. Okay, let me execute this. This is created, the user is created. Now the third is the grant and revoke permissions. So the grant is used to give the privileges to the users and the revoke is used to remove the privileges from the users. Here is the syntax: grant privilege on schema, then schema name to username. Okay, and then the syntax for the revoke is revoke privileges on schema name from the username. Here is the example. So let's check this in a real time. So okay, here is the grant. We are giving the grant to the select, insert, update, delete, alter, execute on the schema, that is the schema one, and the my user. Let me execute this one. Okay, okay, create schema. Now we have given the grant permission to my user. Okay, my user one. So privileges can be given either to the user or to the schema. Okay, to view login name and the username, you can go to the view object explorer, double click on security logins and then the name. Okay, so let's check this in real time. View object explorer, go to the security, then the logins and login name. Here you can see, if you click double click on this, then it opens and it gives means allow us to change the password, then the confirm password, and if you click on this, then the password will change. So to view username, so you can double click on the database, system databases. Let's check this one is database, system database, then master database, security, users. Let me refresh this. Okay, here you can see the my user. A schema can be deleted only when it is empty. So the next is the SQL Server agent. So what is the agent? So SQL Server agent is a tool or service used for automation of administrative tasks, and the tasks which are then manually can be performed automatically by using the SQL Server agents. So in this tool, creating a database, managing database, import data, export data, backup, restore, creating users, managing users, database replications, log shaping, database mirroring can be performed. Database replication means it is the process of copying or moving data from one database to another database in the different systems in networks. Log shaping means it is the process of creating a backup file in the production server and restoring it in standby server in the network. Database mirroring is the process of maintaining two copies of a single database in a different system in network. The first database is called as the principal database and the second database is called as the mirror database. SQL Server agent contains job schedules, alerts, etc. So a job will contains a set of steps and each step will contain one DBA command. Okay. When the job is executed, then all the steps will be executed one by one. Schedule is used to specify when the job should be executed according to the given date and time the job will execute. Alerts are used to give notification or messages to the users about the status of the job, like whether it is completed or else in process or else in it is failed. So why we use the SQL Server agents? So in the real environments, no one run things manually every day. So we can use the SQL Server agent to take the database backup, full backup or differential backup or the log backup, run maintenance tasks like index rebuild and the cleanups, to run the ETL or the data load processes, to monitor the servers and to send alerts, to automate admin work at fixed times. Simply put, it saves times and avoid human mistakes. So what are the core component of SQL Server agents? So the first one is the job. So the job is a container for work. A job can have one or many steps. Steps executed in sequence, and if one step is fails, you can control whether the job stops or continues. So here is example of steps. Okay, job steps in jobs. So the first step is create a or check database. Then the second one is the take backup. Third one is the clean up old backup, and the fourth one send success or failure emails. The second core concept is the job steps. So each step run one task. Okay, a step can run transaction SQL command, SSIS packages, or the PowerShell script or operating system commands as a DBA. 90% of the time you will use the TSQL steps. Okay, and each step has success action, failure actions, the retry logic, and this is the very important in production systems. The third one is the scheduler. Schedules. A schedule controls when the job runs. A schedules can be a one-time schedule, daily schedule, weekly schedule, monthly schedule, or every few minutes or hours. Okay, so here is the example of schedule is this: full backup every night at 12 a.m., log backup every 50 minutes, maintenance job every Sunday, or the job without schedule can be run manually. The fourth one is the alerts. So okay, so the alerts are for monitoring. They notify you when something goes wrong, like job failure, disk space issues, severity issues in severity errors in SQL servers, SQL server service problem. Alert usually work with the database mail to send emails to the DBAs. The fifth one is the operators. So the operators are the people who receive the alerts. So you can define the name, email address when they should receive the notification. Alert per operation equal to real-time monitoring. So the SQL Server agent in real-time production live in the real projects. Every production server has agent job. Backup are never manual. Jobs are monitored daily. Job history checked every morning. Alert are mandatory for failures. If SQL Server agent is down, that is the critical issues. And the one golden rule for experience is if task is repeated more than once, it should be automated using the SQL Server agents. So if this video helped you, hit like, follow and subscribe to the Gentech channel. Thank you.